Hello, welcome to another stream. How about that? How about that? But you didn't expect that. Welcome, welcome, welcome. So today is Friday, and that means today is the day of Fry. So that means today, according to the schedule, we're doing a one-off stream. On the one-off stream, what I do, I just pick up a random topic that I wanted to do for quite some time, and I just stream it for the whole stream. So yeah. And today's random topic is generic programming. That's right. So we will go into that a little bit later. Hello everyone. Hello Ivanhoe, hello Igudu, hello Tapco Wild, hello Thraix, hello Supercali, Woodness, Spark343, CPP is Power Programming, Hazel Haskell, I hope I pronounced your name correctly, Seldard, John 5+8, I think I acknowledged you, John Puft, hello, Aritra, welcome Ivanhoe, hello, Zikanfik. Welcome. So yeah, what is generic programming? So does anybody know what the fuck it is? Essentially, not generic, genetic. Why am I saying generic? It's a genetic. Everx, welcome to the stream. How are you doing? So let me sip my water and we'll go into that. So essentially, genetic programming is usually used in artificial intelligence and for optimization problems, right? These days, as far as I know, people quite often use it for neural networks, but I think maybe this kind of approaches got replaced by more fast and advanced methods. So the idea is the following, right? So you have some solution, or for example, you can imagine that you're writing AI for some sort of a bot, right? So you generate random AIs for several bots, and you just let them play a game by certain rules, right? And then after they play the game by certain rules, you can measure their performance. And their performance is going to be the cost function that you're trying to optimize, right? So then you take the best performing bot, the best performing implementation of a logic of a bot, and you essentially breed the next generation, so to speak, right? You introduce random mutations to the AI of that bot, and then you let the next generation play again. And then you pick up the best performing bot, and you repeat that process until you know the function converges, right? So until the function does not improve anymore, and you'll get AI implementation that is, well, optimal enough. It has like a local optimum for a particular cost function. So, and people quite often associate genetic programming with neural networks because in case of a logic of a bot, you can use a neural network, right? So, but as a matter of fact, you can use genetic algorithm with anything, right? Any optimization problem could be attempted to solve with genetic programming. So it is not necessarily like a neural network thing. And this is exactly what I wanted to explore. I haven't read much about genetic algorithm. I know only the basic concept, and I wanted to explore that idea myself, right, without reading anything. So as I usually like to do, which is kind of stupid, I know. So because you're supposed to listen to smarter people, but I tend to just try to experiment myself just to understand things better. So I'm gonna just get that idea, and I'm gonna just try to play with it. So what I'm gonna do, I'm going to try to generate optimal AI implementations for bots that play by certain rules. So yeah, that's pretty much the idea. The first half of the stream is going to be me implementing visualization and the game for which we're doing optimization, and then the second half of the stream is going to be like actual genetic programming. So does it sound interesting? Does it sound interesting? So yeah, I haven't decided on the language yet, but I think I'm going to go with the safest option for today, which is going to be C. And for visualization process, we're going to use SDL, because this combination of technologies I'm the most familiar with. So I won't be stuck reading documentation or Googling too much stuff. I can just quickly implement all of that and just get going. So this is not like bioinformatics programming. No, it's a completely different thing. It's a completely different thing. Alright, so let's create a separate folder. I'm gonna call it GP or whatever, right? And let's get started, I suppose. So it's gonna be usual C project, nothing special. Usual C project. It'll be main C. Emacs is a little bit slow for some reason, I don't know why, but it was thinking about something. So let's actually quickly include everything. Yeah, so here's gonna be the hello world situation. And we're gonna create a makefile. So I have not come up with a name for the repo yet. Because, you know, the good name for a repo is half of the success. So yeah, I should be a little bit more responsible for that, but I don't know. I think I'm gonna call it GP. Once we get into like a little bit deeper into the implementation, maybe the name will be more or less obvious. We'll see. But for now, I'm gonna just do it like that. So I don't want to include WR because it causes more problems that I would like to. So I'm gonna include debug information. I want to use the relatively data standard, and what else? Maybe I'm gonna make it pedantic, just in case, because why not? So libs, we're not using any libs right now, and let's try to compile this thing. The thing was not compiled because shell something. Excuse me. What the hell just happened? Syntax. Oh, I forgot. Okay, I see. I'm sorry. I'm an idiot. All right. So now Since C11, so modern. Yeah, exactly, I know. Git ignore, and we're gonna git ignore this GP, and I'm gonna create this as a git repo. So then we're gonna do a committee. On top of that, I think I'm gonna start writing README super quick. Genetic programming. Just a playground repo for my genetic programming experiments. So we're gonna have like a quick start. So a quick start, there we go. And in the quick start, we're gonna have something like you have to do make, and then you're gonna just run it. So as we implement more and more features, of course, this kind of thing is gonna become more and more complicated. And also, I want to provide a license up front, so I don't have to think about it. Alright, so let's quickly copy paste this stuff. GPL, yeah, sure. So let's include everything and do ready, set, go. And I'm gonna upload that to GitHub right away. I'm gonna upload that to GitHub right away, and I'm gonna just call it GP. Just a playground repo for my, yeah, there we go. And it's gonna be public, of course. Let's not forget to make it public. And yeah. Let's copy paste it, and I'm gonna just add origin. There we go. So origin has been added, and let's push that right into the repo. All right. So the you know, the boilerplate is ready. I mean, the skeleton of the project is already available. So, and I'm gonna push there as I go. Have you heard about GitHub CLI? Yes, I heard about it. All right. So maybe it makes sense to update project command. So today we're experimenting with genetic programming. So source code, https github.com Zojin GP. There we go. The project command has been updated and we're ready to go. So what I'm going to do, I'm going to start with the visualization, right? We want to actually be able to see what is going on. Right? So let's use SDL for that, because I know SDL really well, so I don't have to like learn it from scratch. So SDL, SDL.h, I think it has to be SDL2.h. And if I remember correctly, you have to do SDL init. SDL init video. We only need video for now. And then we're gonna SDL quit. There we go. So this is like the smallest SDL application that you can ever write. And if I remember correctly, in package config, we have SDL somewhere, right? So do we have it there? Do we have SDL2? Yeah, we do have SDL2. Packages, SDL2, package config, cflags, SDL2. Similarly here, package config, libs, SDL2. There we go. So let's try to compile that now. So it can't find SDL2. I think it has to be like that, if I'm not mistaken. Yeah, there we go. There we go. Now we're talking. Yep. Cool. So after we initialized SDL, by the way, SDL can fail if I remember correctly. So you have to always do things like if SDL less than 0, that means uvu, your SDL did fucky wacky. But I mean, you have to do something like that. So SDL get error, right? And then you have to exit with 1. Sorry. At first I read it as generic programming, but genetic is even more interesting. God damn it! So a lot of people actually read it as generic. Maybe I should do something about it, because I mean, the performance of the clickbait is actually weighted. I'm gonna put like I'm gonna make it like a capital T. So you know what? What if I capitalize all of the yeah, I think it's okay. So genetic, yeah. What kind of game we will create? I am not sure. So we'll see. We're gonna have like agents that compete with each other, maybe for resources or maybe for survival, and we're just gonna you know, let them play the Hunger Games. By the way, Hunger Games could be actually a pretty interesting idea. So yeah, essentially, maybe there are some entities, they have some sort of a hunger, and what they can do, they can find food in the environment, or they can eat each other, right? So, and what we will let them do, we'll optimize for how long a particular agent will survive, right? So this is what we're gonna optimize. So that's actually a pretty cool idea. Yeah, it's kind of like, yeah, oh my god, this is actually cool, because spore, like the first stage of the spore, let me tell you, by the way, I'm pretty sure you can take spore, take only the first stage of spore and throw away everything else, and you would make like a fucking banger game, right? So everything else after the first stage of the spore is just fucking like not worth playing, like come on. It's not even that interesting. But yeah, something like spore would be interesting. But I don't really want to overcomplicate it. I'm probably gonna make it on a 2D grid, so it's gonna be cell-based, so it's a little bit easier to work with and stuff like that. No, Among Us is the game to play at the moment, so you gotta... I don't know. Among Us sounds like just you know, just a glorified Mafia, to be fair. Yeah. Because I think it's literally Mafia, you know, the party game. Alright, so let's go to here. And I want to go to SDL, and I want to find... hello everyone who just joined recently. Hello Fish, Square No, Anaton Codes. Hello everyone. It is similar to Mafia. Well, I mean, in Mafia you don't perform the tasks, you don't go around, you just like sit in the same room. So it's a little bit more interesting than Mafia, but the idea is actually kind of like very close, I think. So we need to create a window first. So let's see where we have such function that creates a window. Here it is. This is how we create a window. So first you initialize SDL, and then you create a window. So then you'll have to create the title of the window. So the title of the window is going to be what? Hunger Games? Question mark. So then we have a position of the window. So initially it's going to be 0, 0. I don't think it matters that much for me. Project Winter is pretty interesting. I don't know what is a Project Winter. Excuse me. Width and height. Screen width. Screen height. Alright. So what kind of flags do we have here? Oh, SDL. Wait a second. SDL has a Vulkan backend? I didn't know that. I thought it's only OpenGL. That's actually pretty cool. Oh shit. So essentially, yeah, if you're using like a purely SDL application, if you're making purely SDL application, like for example my game, something, it can potentially work on Vulkan. Yeah. So I know that you can also use DirectX, and you also can use Metal, right? So, but I didn't know that they support Vulkan. Huh. I don't know why I didn't know that, but it's just interesting. Okay, so what kind of flags do I want to have here? I would definitely want to have like a resizable thingy. Okay, so window. So regarding my keyboard, yeah, use keyboard or check out FAQ, because it's a frequently asked question, so it was asked many times. So obviously I already have it answered there. I do in fact already have it answered. So if this thing returns null, we have to do this thing like that. There we go. So after we created a window, after we successfully created a window, we have to create so-called renderer, so we can render on that window. So yeah, I have to do like a screen width. Just a second. So it's gonna be 800, and this one is gonna be 600. 600. It's not just a keyboard, it's a USB keyboard. Thank you very much. You know, pretty advanced these days. It just renders the Vulkan output, but you stop using SDL for drawing altogether and you're left with just events, music, etc. Yes, I know, that's the point. Yeah. Alright, seems good. Does it work? Alright, cool. So let's create the renderer. SDL create renderer. Grab RN, SDL create renderer. Here it is, here's the function. So const renderer. So to create the renderer, we have to provide the window. Right, here's the window, and we have to provide an index. As far as I know, it's an index of the driver. So we can just put 0 here. The index -1 to initialize the first one. Okay, so that makes sense. So it's going to be -1, and flags are SDL render flags. So let me see what we can have here. Yeah, here they are. So we're gonna use the hardware accelerated graphics here. Right. So there we go. And if renderer equal null, it's gonna be like that. Using GPU, exactly. We're gonna use GPU for genetic programming. How about that? I mean, for visualization. But you already have an opportunity to say that I'm using GPU for genetic programming. But all you're doing, you're just visualizing it. And fucking classic buzzword debate. Isn't this how you become like popular on not on Stack Overflow, but Hacker News and stuff like that? You basically debate people with bullshit and buzzwords. Yeah, essentially. What if you want your game to have 2 renderers that can be selected in options like in Counter-Strike? I don't think the renderer in SDL is the same thing as the renderer in Counter-Strike, and I don't think you want to do that. The fuck is genetic programming? Genetic programming is basically programming the same way as the nature programmed us. Is that a good explanation? Because nature programmed us in a very specific way, and we can use the same technique to program our programs. Right, so using natural selection. So instead of writing programs directly, you just let programs compete with each other and devour each other, and the program that survives is the program that you want. I'm not even fucking joking, this is literally what genetic programming is. You just let the thing that you're writing compete with each other and mutate and evolve over time. So, like biological programming, I know nothing about biological programming, but genetic programming is basically that. There's different techniques on how to do that and how to move forward in optimization, but yeah, that's pretty much the idea. When would you use GLFW and when SDL if you don't care about the sound? Well, I don't know when you, but I use it right now because I don't want to think about OpenGL API, and I know SDL API relatively well, so I don't have to Google things much. So that's pretty much the answer. Alright. Is it a gimmick or is it worth reading upon? I guess it's worth reading upon. Yeah, why not? Sure. I mean, genetic programming is a thing. Just put it into Google and you will see that, yeah, there's an article about that. There's articles, several of them. So, alright, let's actually start handling events. Right, let's start handling events, and I think it had to do something like SDL poll event, if I'm not mistaken. SDL poll event, and then we're gonna check event type. Hamikovi, welcome to the stream. Welcome, welcome, welcome. My God, really glad to see you. Really glad to see you. All right, and when we are about to quit, we're gonna put this thing here. So if I remember correctly, we have to do something like SDL render clear color. SDL render clear something something. Yeah, render clear. I'll add a Google bookmark on this to check it out. Nice. Please keep me updated. I'm very interested in your endeavors on learning this topic. This is very important for me. Thank you. Thank you so much. All right. So then we're gonna do SDL render clear and less than 0. You know what? I don't understand why I'm not using my usual trick with, you know, a special macro, a special function that wraps around all of this error handling. I think I should do that. He's making fun. I'm not making fun of you, seriously. I want you to learn new things. I want you to improve as a software developer. Yes, I'm not making fun of you. Why would I make fun of you? Come on. I genuinely like you. So let's actually create a couple of like macros and stuff like that. So it's going to be SDL check code, which accepts the code, right? And maybe it can return the code, but I'm not sure if it needs to be returned. So code is less than 0, and then yeah, if it's less than 0, we're going to do something like SDL error, yes, SDL get error. So this is going to be an exit, and we're going to just return the code. So, and after that, I don't really need to do this kind of checks all the time. The only thing I have to do is just SCC, and there we go. So, and every time I need to do this check, I can just wrap things around. Like for example, here, I don't have to do that anymore. I already demonstrated that trick. I don't know why I stopped using it here. Maybe I just forgot about it. That happens to me from time to time. But this is not going to work for functions that return pointers, so we need to create like a separate one for the pointers. So this is going to be like this: SCP ptr, if ptr equal null, SDL error, SDL error, SDL get error, exit 1, and we're gonna just return the pointer. All right, so in here, essentially what you can do, you can remove this scheisse and do SCP like this. And my Emacs indented this thing because I forgot to put a semicolon here. Silly me, silly me. So now I can remove this scheisse as well and put SCP here. There we go. You see how code is reducing in size? It gets compressed, it gets improved. It's pretty cool. It's pretty fucking cool. Alright. So let's try to do compiling. What am I even fucking doing? There we go. -B. So render clear. Render clear. I think you also have to set a render draw color before cleaning anything. Yeah, that's what you have to do. Use a zip utility for compressing the code. I can use gzip. So now it's gzipped. But you know what's cool about Emacs? I can open it. And you know what's even cooler? I can save it, and it will compress it back. Emacs can edit compressed text files. This is not even a fucking joke, seriously. And it keeps it compressed, so it's uncompress it and put it into the buffer. You can edit it and then compress it back. I can even tell you, it can do even cooler things. I think it can work with GPG files, the encrypted ones. So essentially, if you have an encrypted file, it will, upon opening it, may ask you a password. You enter the password, it puts the file into the RAM. You can edit it, you can try to save it back, and it will ask you the password again, and it will encrypt it back. So you can actually have a workflow in Emacs where you never store unencrypted data on a hard drive. Can your Vim do that? Get him. Actually get him. Alright. Will it create temporary files in the past? I don't know, to be fair. I never checked that. I think it shouldn't. Because as far as I know, GPG can output the encrypted file into the standard out. So technically, Emacs can use that mechanism. Right. So it basically encrypts, it sends it through the standard output, and it saves it into the buffer and keeps it only in memory. But I never actually checked that, so I don't know 100% if Emacs, you know, doesn't create any temporary files. So yeah. So I was half joking, of course, that, you know, it's such a cool thing. But always do your own research. Always do your own research. All right, let's continue. So I need to set the render caller. So I'm gonna set the render caller, and of course this thing can probably fail. So what's gonna be the render caller? The background color, I mean. So 150, 150, 255, and then we also have to swap the buffers, I think. SDL swap buffers. It's not GL swap buffers. I think it's present. The first time I used Vim, it was a nightmare. Yeah, that's basically the point. That's the point. Alright, so boom. There we go. Should be working now. Should be working now. And there we go, we have a window. So we have a window that can do things and stuff like that. Yep. So I think it's too bright. It's a little bit too bright, I would even say. So it's gonna be maybe something like 30. And we can try to compile that, and it's gonna be GP. And yeah, there we go. So it's a little bit better. The background is really similar to the background of Emacs that I have right now. So overall, it's okie dokie karaoke. So as already said, I want the game to be on a grid, on some sort of a grid. So let's actually start visualizing that. But before we're gonna do that, I wanna do a committee, and then maybe even push. So let's document dependencies. I think I spelled it correctly. SDL2, and we're gonna have it like that. SDL2. Let's find SDL. Simple direct media layer. So these are the dependencies. Implement basic SDL application for visualization of the optimizing game. And I don't have enough space there, but do I care? No, I don't. Let's push that. So yeah. So the source code that I just implemented is already available here. So there we go, there we go. So we're gonna have a board on which we're gonna actually do all of this stuff. So let's say something like board width. So how many cells on the board we're gonna have? Let's say it's gonna be 100 by 100, because why not? Board height is gonna be 100. So, and maybe we're gonna try to render that the grid of the board so we can see how it goes and stuff like that. So let's quickly do that. So render board, it will only accept the renderer, right? The renderer, and we're gonna try to render that thing. So render board, renderer. So did I forget a semicolon? It feels like I forgot a semicolon, but not really. So everything seems to be okay. Alright, so what I need to do now, I need to iterate all of the columns and maybe iterate all of the rows and just, you know, render lines that denote the stuff. So let's do it like that. And what am I iterating right now? I think I'm gonna iterate X. 0 less than board width plus x. Okay. Interestingly enough, we need to know the size of the window. I wonder if I can get it somehow. SDL get size of window. I think I'll have to pass the window size. Well, yeah, this is because this is not really reliable variable, because the window is resizable. Right, so the window is resizable, so that means we have to get the actual size of the window. Right, and to do that, we'll have to use this function, and this function accepts a window. This function straight up accepts the window. So, but do I want to put a window there as well? Might be actually a good idea, because why not? It may work for now. I think it may work for now. So, and we'll have to provide the pointers to these variables and stuff like that. Excuse me, I'm going to do like that, and int the edge. This is Nur, welcome to the stream. How are you doing? So yeah, now we have width and height. And we need to calculate the size of a single cell, right? Wait a second. Why am I even doing all of that? Can't I just do the similar thing as we do in something? Remember, you guys know what we do in something? Wait a second. Yeah. So essentially, I actually solved that problem in something a long time ago. What am I even thinking about? Jesus Christ. I'm an idiot, I'm sorry. So essentially, in something we have a similar problem, but what you can do now in SDL, you can fix the size of the canvas you're drawing in, and basically fit it into the window, and it's gonna like stay the same. Why can't we just use the same thing, like fix the size of the window, right? And you can draw however you want, and you don't have to worry about that anymore. So yeah, I think this is exactly what I want to do. I'm gonna just port a little bit of code from something to Hunger Games. So, Gain of the Grey of Hell, welcome to the stream. How are you doing? Welcome. Cheers, by the way. All right. So let's continue. So that means I don't have to pass the window. I just don't have to do that. That's stupid. Fuck that. And I can only rely on hard-coded screen width. So, and it also means that I can define the following things. So, for example, cell width, which is essentially... Oh, this one is interesting, actually. Screen width divided by board width. Right. So, and that gives us the width of a single cell, but at the same time, I want this thing to be a float, which is very interesting. Wait a second. Chat, what do you think? If you have something like this, what's gonna be the value of x? Is C compiler smart enough? It's gonna be 0. Yeah, I knew that. Fucking knew that. So I thought maybe the C compiler is smart enough to actually think, oh, okay, it's a float, so I'm gonna do a floating. No, it is not. So, and because of that, if I want cell width to be float, I'll have to do something like this. Yeah. Or maybe only once, but I'm gonna just convert them just in case. Oh, wait a sec. Nah, it's not gonna work easily. Yeah, I just thought maybe I can do something like F, but it's not gonna work with macros. Only once is enough. Yeah, I know, but yeah, only once is enough for sure. All right, and cell height. So it's gonna be cell height divided by board height, and there we go. So we have these constants defined. I don't know why I thought that maybe it could work. Is that Vim? Yes, this is Vim. This is Vim. Vim is my favorite text editor, by the way, believe it or not. I love it. I absolutely love it. SDL render line. Beam. Is there like a text editor Beam? Beam text editor. The fuck? Okay. Small terminal text editor with syntax highlighting. There you go. There's Beam. So how popular it is? It's actually, well, it's not that popular. I mean, but it's relatively okay. I'm pretty sure I don't have that thing in my repo. Nah, I don't think I have it. Don't think I have it. So it's written in C by, oh my god, it's written in C. So that means it should be relatively easy to just build it on my machine. So I'm gonna quickly do git clone. Oh shit, it just works. What the fuck? The fuck? It's actually Vim. It acts like a Vim. Wait, what the fuck? I can do DD, but main.c beam.c doesn't have a syntax highlighting though. Like they promised that there will be syntax highlighting. Syntax. Beam is terminated with the syntax highlighting, but how do I enable it? Syntax C. Well, but it's actually quite impressive that you just build it quite easily and it just works. So it deserves my star. Like, I mean, it's just scroll down a bit. Okay, where's the... Okay. Anyway, so this is not the topic of today's stream. It's pretty cool. Out9, hello, welcome to the stream. So yeah, we're doing genetic programming. I keep saying generic, but it's actually genetic. So right now we're developing a game, for which the agents of which we're gonna try to optimize. And yeah, I'm just doing a little bit of visualization, nothing special. We'll see how it goes. How do I render a line? SDL line, render line. Hunger Games. Yeah, we're gonna do Hunger Games. So essentially, the idea is that the agents, they gonna try to stay alive as long as possible, right? And their behavior is gonna be encoded in maybe like a Turing machine thingy. And we're gonna try to optimize that using genetic programming. We'll see how it goes. And whether I'll be able to pull that off, because I'm not sure. All right, so let's go. So the x starts at x multiplied by cell width. So here's the cell width. This one is gonna be 0. This one is going to be x cell width, and this one is going to be screen width. There we go. It's going to be screen width. So this is the first line that we're rendering. This is essentially the first line we're rendering, and let's try to run it. Okay, I couldn't see anything because we don't set the color. We don't set the color, so we need to set the color first. So what's going to be the color of the line we're drawing? So I think it has to be something a little bit brighter. 150 maybe? Ah, there we go. So maybe it's too many lines, to be fair. It feels like too many lines. And it's actually very, very bad, so I don't think rendering a board in this particular situation is a good idea, but yeah. Unless you have actually less amount of cells. So if you have like 10 of them, rendering board like grid explicitly would probably make sense. And it didn't work for some. Excuse me. Oh, I'm an idiot. Okay. Excuse me. Yeah, there we go. It does make sense now. Maybe 999 instead of 1990. Probably, yeah. So maybe the problem is that it's too bright, right? If it was like this, it'd be a little bit better, even with the a lot of cells. Let's actually put 100 here. Yeah, it's a little bit better. So yeah, thank you so much. Maybe we can make it even more faint than that, like about 60. Yeah, sort of. Alright, but eventually I probably will have to get rid of it anyway. So for now I'm gonna keep the amount of these things low, like 10. Like 10, and this is gonna be something like y0, and we are iterating board height plus y. SDL render draw. I'm not gonna copy paste it. Yeah, it's literally bike shading, my god, because in the bike shade scenario they also discard the color of the bike shade. Fucking classic. Right, so x, if it's a horizontal one, x is gonna be 0. I'm trying to visualize that in my head. Y is gonna be y multiplied by cell height. So x is gonna be screen. I just realized that I did a fucky wacky. This one has to be height. Right. And in this case, it's gonna be y cell height. There we go. And let's do something like this. And epic. So now we have cells and stuff like that, but they don't resize, but that's kind of the point. So to make them see a little bit better, we can just make them a little bit brighter. Right, as you can see, they don't resize. And this is intentional. This is intentional because I want to implement the sort of, well, like a canvas layouting similar in Nothing, right? So because I already demonstrated how it's done in Nothing. Something, I'm sorry, it's not Nothing, it's Something. Right, so essentially the canvas, it has like the constant ratio. It has the constant ratio, and I want to do the similar thing here, so I don't have to worry about resizing, and I just can hard code the size, and SDL actually enables us with doing all of that. Do Game of Life, but with genetic programming. What are we optimizing there, by the way, if we're gonna do genetic programming on Game of Life? For how long a particular combination lives? Life itself is okay. So yeah, essentially we generate a random state of the board, right? And we just let it play until it starts repeating itself. But detecting that it repeats itself is actually kind of difficult. I don't know. We need something to optimize. Yeah, I'll think about that. But for now, yeah, I'm gonna keep implementing the game. But it's actually a very interesting idea. I'll think about it. Yeah. So I need to go to something and see how exactly we do that, because I don't remember how we do that. This set logical. That's a lot of shit we have here, to be fair. Render set logical size. Yes, I think that's the function. That's the magical function we always were looking for. Render set logical size. Dependent resolution for rendering. Do we set anything else? I didn't think we set anything else. Okay, so I'm gonna just grab that function and see what's gonna happen. So this is a screen width, screen height. Yep. Okay. As you can see, it basically embeds itself and it also scales as it needs. So, and to keep the cell squared, we can give it a squared size. Essentially, we can do something like this, right? There we go. So, and there is a problems here because we probably have to do an extra step. We have to do an extra step here. So that means I'll have to do something like equals, right? Have to do something like equals, and it didn't work. Excuse me. What? Why didn't it work? Okay. What if I do +1? What if I do +1? How about +1? Maybe it's off screen. Ah, goddammit. Could be. We could try to skip the first step instead then. Essentially like this. Yeah. How about that? Yeah, so now it looks more or less okay, so we have that. Kolumbetka, what's up, Kolumbetka? How are you doing? So, I just want to make it possible to see that perfectly. Yeah, so now it just renders okay. Alright. You know what? I want to rename this thing. Render board. It's not going to be a render board, but let's call it render grid. Maybe even board grid. Okay, cool. Implement rendering of the board grid, and I'm going to push that right into the repo. The source code here is available here already. My English is so pepega. So, okay, we need to come up with the agents, right? So, with the entities that play on the board. So let's define a structure for such an agent. Let's call it an agent, maybe. Maybe it would be like a better name for the things that fight for their lives. It's like, for example, you only need to render the tiles and are in bounds of the camera. I just rendered the grid to indicate the cells because the game is played in the cells. The game is played in the cells. So the agent is going to have a position X and Y, right? So it's also going to have the direction, right? So how are we going to encode the direction? So it's going to have like basically the direction at which it's looking at. So you can have only 4 directions, so it probably makes sense to define some sort of enumeration vector. With a vector you can define illegal directions, right? Diagonal. I don't really want to have a diagonal direction for now. I just want to keep it simple. Oh, and yeah, thank you for reminding me about typedef. Let's actually add typedef like that. So there we go. So so I'm gonna go with enumeration, and enumeration is going to define basically a number from 0 to 3, and we can use that number as an index in some sort of a map of vectors. So yeah, and that way we're gonna eliminate illegal directions. So I think it's gonna be a little bit better. So we're gonna have it in num and then direction, and we're gonna have something like dir left. So I think I'm gonna go with right, and I'm gonna go counterclockwise, similar to how like in trigonometry it goes. It's gonna be up, left, and down. Yeah, copy pasting things like that was not the best idea, so it's kind of bigger. Yeah, there we go. So this is a direction. All right, cool. I think direction is too long of a name. I don't want to type it. So this one is going to be deer. This one also going to be pose. Is this correlated to bioinformatics? No, but maybe genetic algorithms are useful in bioinformatics. We'll see. So right now what we're doing, we're making a small game with agents that trying to survive within the game. What the fuck is this shit, by the way? And we're gonna yeah. And we're trying to I plan to use genetic algorithm to optimize the behavior of the agents, right? So that's going to be the idea. Yeah, it's more of a like genetic AI programming, if it does make sense. So they're also going to have some sort of like a level of hunger, right? So they'll have to eat. They'll definitely have to eat. And maybe they're gonna have like a level of health, right? So yeah. So this is the parameters that we have. Huggers. Oh, hug. Yeah, thank you. Huggers. So it sounds like an emote, like huggers, like poggers and stuff like that. It's huggers. Huggers. All right, so here's the agent, and the agent should be able to perform different actions, right? Oh, there is Hagger, not Haggers, Huggers. I cannot distinguish sometimes between A and I'm such a pepper. All right. I actually have like a free slot, so I added it. I don't know, I just added it because I had a free slot, because why not? So now we have Huggers. We also have a thing, Dank Hag, like this one. So yeah, now we have like 2 Hagmus. Alright. So we're gonna have actions that an agent can perform. Agent action. So the first obvious action would be step, right? It would be step, and the second one probably gonna be eat, right? So essentially, when the agent is on a particular cell that contains the food, they may choose to perform an action of eating that food, right? Yeah. So then we're gonna have attack. Do we need anything else? That's a good question. Do we need anything else? So we can step, eat, and attack. So what's funny is that the agents themselves, when they die because of their health goes down, they will drop food as well. So that means the agents could be actually killing other agents for the food, but there will be also food in the environment as well. So something like that. So far I don't really see many actions. So maybe in the future we're gonna have them, but yeah, we'll see how it goes. Oh, and of course I have to do type diff. Jiang, oh my god, Jiang, welcome. How are you doing? Really glad to see you. So, yeah, let's just call it action. This one is gonna be action, step, like this, eat, and attack. So yeah, what we're doing here today, we're trying to explore genetic programming, and we're trying to apply it to a small simple game where we have a bunch of agents that are playing Hunger Games, I suppose. I don't know, they're trying to kill each other and they're trying to survive, and yeah. Oh, by the way, another action could be nothing. Right. Another action could be nothing. And it makes sense to actually make this action 0 because it's literally nothing. It's nope. Oh, you know what? Nope. Cool. Sleep action. It's like sleep sort of implies like a longer term thing. I don't know. I think I'm gonna go with nope. I'm sorry. Nap. Okay, so we defined everything. So, and we're probably gonna have like a bunch of agents defined as a global variable. Dead. Oh, and they also can have a status of being dead as well. Just closing my eyes for a while, actually. Yeah. Agents capacity. So there we go. Let's call the agents count. Right. So this is how many agents we're gonna have. And here's another define agents count. So we're gonna have like 5 agents for now. And I think that's pretty cool. So the first thing before starting, we need to initialize agents, right? So init agents. We're gonna do them. We'll do that in a pretty straightforward way. We're gonna iterate through all of these things. Agents count. It sounds like a name. Agent count. Reporting. Sorry, yes, sorry. Okay, agents I, and we can do something like a random agent. We also have to make sure that we're not generating agents on the same cell. So can they be on the same cell? What? Am I doing Russian right? Yeah, this is exactly how you speak in Russian. Yes, yes. That is absolutely correct. Cool. Agent. 0. And we'll need to initialize like a random values there. Sure, you can use Google Translate. Starts working. That's right. So random position is going to be within a particular range. Agent, something like this. Random range, random int range, let's call it like that. Random int range is going to be from 0 to, I think, board width. So we're generating from 0 to board width. Y is going to be like this, and then we also can have something like random dir. Hunger. To be fair, I don't think hunger and health should be random in this case, so they can be full. Twerk to make it work. Yeah. So basically, I had this idea that maybe create like a small device with the, you know, motion tracking and stuff like that. So you put it on your lower back, and for example, your program only works when you start working. I'm so sorry, it's so dumb, but that sounds like an interesting project to check. Okay, so we have health, and we have hunger, and it's gonna be 100. Model specifications for Cronus group are so good. Really? I never read them. Alright. So let's just return that. This is agent. And if I try to compile that, of course, this shit is not gonna work because we're using functions that don't fucking exist. obviously, your program is not going to work if you're calling functions that don't fucking exist. Don't do that. Implement your functions. And that's exactly what we're going to do. Alright, so let's go ahead and implement them. So we need to do something like random int range is going to be low and high. Not height, whatever was that supposed to mean, but yeah. Imagine not having built-in random functions. Yeah. Yikes. Dir. There we go. Oh, what's funny is that random dir is essentially random int range, and it depends whether we include high or don't. I'm gonna assume that we don't, and it's gonna be just 4, right? And then you can cast that to dir. Then yeah. STD random distribution. I mean, STD dance game. Alright. So it's gonna do. We're gonna try to find the distance between low and high by subtracting one from another. Then we are generating from 0 to this value, and then we're adding low back. So let me actually check something. It's 1, 2, 3, 4, 5, 6. If I have something like 1 and 4, and if I subtract 4 from, if I subtract 1 from 4, I will get 3. So that means we have excluding high. So random int range does not include high itself. Don't forget void in your functions. Void in your functions. You mean this one? I'm out of the context. I'm sorry. Yeah. Oh yeah. So you mean basically I can do this kind of thing. Right, so, and that means if I don't use a variable, I have to void it. Yeah, so it's a classic C. How are you representing the genetic algorithm in neural networks? I have no idea. I'm not using genetic algorithm for neural networks. So, this stream, by the way, has nothing to do with neural networks at all. Like, completely. Line 88, 89... something... Ah, oh shit. Okay, I'm sorry. Thank you so much. That's actually very important because these functions, if in C, you don't have anything here, that function is variadic. So that means I can call this function like init agents with whatever random shit I want, and it will compile. So yeah, we can even test it out. Let me quickly test that. So I'm gonna compile it, and it compiles, right? So. Yeah, you can put whatever you want, and also any type. PPG. It will just work. Welcome to C, by the way. To prevent that, you're gonna add void, indicated that you don't have any arguments for this function, and yeah, only then it will complain about that. PPG, exactly. It's a very PPG. I think it made sense in 70s, first of all. And second of all, why the fuck are we still using language from 70s? In other words, why the fuck we still have to use the language from 70s? So, what's the program supposed to do? It's supposed to work. So what we're doing right now, we're implementing like a small simulation game with agents and stuff like that, with different behavior. And the idea is to use genetic algorithms to come up with the best AI that can rule them all. Within that game, of course, within that game. You can use language from 80s, C++. You can even use language from 90s, JavaScript. Did you guys know that JavaScript was released in 1995? So yeah, it's a language from 90s, literally. So Java the script. Okay, so maybe I wanna so let's actually do the following thing. I'm gonna first commit that. First commit that, and I'm gonna call it introduce the agents. KGB agents. All right. Initialize the agents, and this is going to be the separate commit. I'm going to push that right into the repo. Shouldn't the random value of pose y, did I make a fakiwaki? Yes, I did a fakiwaki. Thank you so much for pointing out the fakiwaki. So I'm gonna just do committee, fix the fakiwaki. There we go. I'm gonna push that right into the repo. Wow, you look like a magician. Is that a compliment or an insult? I don't understand. Is that initialize the agent? By the way, hello to be Meister. Welcome to the stream. Welcome to the magician stream. So the next step we probably want to do, we want to be able to render those goddamn agents. Right, so we're gonna do render, and I'm gonna sneeze. Thank you very much. Bless you, Zulu. Thank you. Render agents. Be healthy. Thank you so much. We're gonna accept the renderer, and we're gonna try to render those motherfuckers. So I suppose we can just iterate over that. So it's gonna be agents count. Happy sneeze. It actually went quite well, I gotta say. So let's call it render all agents, and then we're gonna have like a render single agent. So the reason why I don't want to actually put all here, so we don't have two functions that one ends with S and another one doesn't end with S. So yeah, so it's a little bit less error prone. So renderer, and what I'm gonna put there is gonna be agents I. Do we want to actually pass it by a reference? Maybe, but it's actually renderer. So, render agent is still a renderer. Agent. So maybe it makes sense to actually pass like indices of the agents. I don't know, we'll see. So how are we gonna render them? So I would like to render them as triangles. Unfortunately, SDL does not provide any way to render triangles. The reason why I want to use triangles is because the agents have direction. So yeah, we need to be able to do something about that. Pass just the index. Maybe I will. I'm not sure yet. So SDL set render draw color is going to be the renderer. And what's going to be the render color of this thing? A bunch of lines in front of triangle. Yeah, we'll see. I really don't like how we represent the colors. I really don't like that, like, because it's kind of difficult to, for example, define a constant for that particular color. So what I'm thinking is that it would be actually pretty cool if we had something like this. Background color, right? So here's a background color, and I could define background color like this, maybe even without the hash. And then we could have a function, SDL set color hex, color hex, and we're gonna accept this thing here, hex. And what this function will do, it will just parse this thing and use SDL set render color, SDL set render draw color accordingly. So I think that would be actually pretty convenient. So we can use different, like maybe websites to come up with a palette or something. Yeah, I think I like that. So let's see how we can do all of that. So first of all, quite important, hexlen, strlen. So we expect hexlen to be equal exactly 6. Yeah, I think we're gonna expect it equal to exactly 6, because I don't think we need to define alpha yet, so it's gonna be just 6. Right, so the next thing, we need a function that will convert one, how do you call them? 1 byte. Yeah, so that will convert 1 byte. So we can do something like uint8 parse hex byte, and it will accept char byte hex. So, and it basically makes an assumption that it can access the byte under the pointer and the next byte after that, and you're supposed to check that. So by itself, this function won't check that. Right. So, and essentially, how we're gonna do that? Hex char to let's call it hex to dec. So we do byte hex multiplied by 0x100 plus hex to dec byte hex plus 1. You see what I'm doing here? You see what I'm doing here? Right. So and essentially we should be able to do the following thing. Yeah, so we're also going to accept the renderer. Of course this thing can fail, so we have to accommodate that. So parse hex bytes, so we're gonna parse the first byte here, then we're gonna parse the second byte plus 2, and then we're gonna parse the third byte plus 4. You see what I'm doing here? Right, so it's a super easy and quick way to sort of parse these hex colors. How did you learn to type that fast? I was practicing a lot, so like it's not like typing is something that you can just read a book about and instantly start typing. You just do that long enough until you can do that fast. And I'm actually not that fast. My type speed is usually around 18-90 words per minute. So it's not that fast because, for example, Pylada is fucking crazy. I think his speed is around like 120. Or something, I don't know. What is the relation between OpenGL and SDL? OpenGL is a little bit lower in level than SDL. SDL is higher. SDL is usually built on top of OpenGL. Okay, so then we're gonna have like this function hex to dec. So in here we accept an x character, and essentially if x is less or equal and x less than 9, we can instantly return x minus that. Right. If this thing is this f, right, we're going to return a plus 10. Why people are so concerned about fast typing? I have no idea. To be fair, like, fast typing is usually never like a bottleneck of software development. So in real software development, you're probably gonna spend more time thinking about the problem than actually typing anything. And the only reason why I'm typing so fast is because I'm actually solving problems that I solved before hundreds of times. So I already know what I'm doing. But if I'm working on something new, I don't really type that often and that much. So int string, does it cast? I don't see any conversion of int string here anywhere. I don't know what you're talking about. I think Dennis looking at the keyboard. Exactly. Seriously, even Dennis, like, he doesn't even know how to touch type. It's not that important of a skill. It's a nice to have skill, but it's not mandatory or anything. So in here we're gonna do assert invalid hex character. To be fair, like it would be nice to know what exactly the like invalid type like hex character we got. I think it would be quite cool. So just a second. So, oh god, my keyboard has died. Speaking of fast typing, I was typing way too fast and my keyboard died. I think there's something with my wire, or I mean cable. So sometimes it just dies and doesn't want to do anything. Oh, there we go. Now it works. I don't know what happened. I'm really sorry. Just a second. Just trying to lay out everything on my desk properly, so I can type. Continue typing fast. So here, what I can do printf. Regarding the void thing, you can add wold style definition to check for it on GCC. It's actually a pretty cool idea, thank you. I'm gonna do that. I think I do want to do that because I already got burned for that one time. I really like this word, wold. I think it's a pretty cool word. 1 second. Yeah. Wold. I'm not just old, I wold. Wolds. Thank you for wolding me. I really appreciate it. Wold style. Wolden. Sounds almost like. Is that even a word? Does it even mean anything in English? I'm not sure. But I like how it looks like when it's spelled. I think it makes it look like it's a legit word or something. Okay, incorrect hex character. It does mean something. Okay, let's go to Macmillan Dictionary. Macmillan Dictionary. Okay, so tell me, what is wold? Wolds. There's wolds. Higher in the countryside with many small hills and few trees. UK code? Cool. Interesting. Huh. Nice to know. Incorrect hex character. So we're gonna put this hex character here. And after that, it makes sense to, you know, exit with one. Error. Cool. So it's wild with O. Oh, okay, so I see how it's translated. Nice. So this is how we're gonna quickly parse the color hex, right? We have a couple of auxiliary functions, like parse hex byte, and essentially you just, you know, like have an imaginary window of two characters, and you just move it, and you just parse everything here. And so you can define colors like that. And that took not that many lines of code. It took only 3 functions and 24 lines of code, and there you go, we can parse hex colors and stuff like that. And it's even safe, right? So we don't have like much buffer overflows because we check for the length of the string, and if you have an incorrect character, we just crash. So yeah, who needs Rust to write safe code? Am I right? And here, by the way, for alpha, I have to do 255. There we go. 255. So we don't have assert. Is this what they call defensive programming? Yeah, I think so. To be fair, like I have a very defensive style of programming because I'm really keeping track of all of my invariants of my functions, arguments, like I always keep them in mind. And if the type system doesn't check them, I always try to put an assert or some sort of a check or something like that to let the program crash and tell me what exactly happened. And that saved my ass so many times, you won't believe it. My god. Okay, so here, when I'm rendering the agent, so yeah, I'm gonna actually go and what the hell is going on? I'm gonna go through all the places here, and I'm gonna try to do something. Right, instead of doing that, I'm gonna do SDL set. How was the function called? I forgot the name of the function. SDL set color hex. Yes, hex. Set color hex. SDL set color hex. There we go. So I provide a renderer, and I can do something like background color, right? So I don't have to do this kind of thing anymore. And the background color is the same color as, for example, the background of my Emacs right now. Set render color. Okay, and this is a grid color. SDL set color hex, so renderer. And it's gonna be what? Grid color. It's gonna be grid color. Yep. So I'll have to define this a little bit up there. Maybe it's a dumb question, but if you assert how SDL release its resources, yeah, the Columbia actually answered that. The operating system does that. Because what kind of resources does SDL allocate? It just opens files and allocates the memory. So if the program exits with the exit syscall, the operating system just closes all the file of the process and deallocates all the memory. So you don't have to worry about that. So the only problem could be with network, but I don't know if SDL provides any network capabilities, does it? So I don't know. But what if... Well, that means you have to reinstall your operating system, so something went definitely wrong. I don't think it does. You mean speaking... You're talking about network. As you then close the program with syscall, it's better to reboot PC. Yeah. Sure. Alright, let's see how all of that Shanghai's work. So this thing is not needed. Let me actually do it like that. Assert render agent is not implemented. So maybe I'm gonna mark it as to do. There we go. And does it even work? It doesn't seem to be working. So what if I make it like very red, the background color? Yeah, it doesn't work. It straight up doesn't work. I wonder why. So maybe it makes sense to do a little bit of a debugging. You guys are ready for a little bit of a debugging? So GDB, GP. So you understand Droka question? Alright. It will overflow. Ah, god damn it. Shit. Thank you. Thank you so much. So it's not supposed to be like, oh my god. It's not that. Oh shit, I'm an idiot. It has to be this. I don't know why I thought it has to be like 100 in hex. Yeah, thank you so much. Now it makes sense. It straight up makes sense. Jesus Christ. I'm a Pepega. Pepegist Pepega. Okay, cool. So, okay, cool. Okay, cool. Now I can define colors like a palettes of like colors and stuff like that using just hex colors. Remember Cloud9 actually gave a website for colors, and I forgot to bookmark it in this account. Probably have to find it. Get them. And my Discord has worked, so sad. It's fucking sad. Just a second. I think I know what's going on. It's looking for searching for class value. Thank you, GitHub, very helpful. What is Relu? Oh, okay, I see. So, I see what's going on. Yeah. Very funny. Yeah, GitHub is very helpful. Yeah. Okay. What I was doing, I don't quite remember. Okay. So, I want to introduce the color of the agent. Right. Yeah, colors. Yeah, colors. Thank you so much. For some reason, I couldn't search in Discord right now. Maybe because I'm in a streamer mode. Thank you. Because if you try to search while you're in a streamer mode, why are you asking so many questions? By the way, let's generate something. Yeah. Let's go. Hit the to generate random color palette. Oh, I see. For some reason, when I first saw it, I thought it's will generate for you automatically. Okay. Okay, I see. So it's using color theory to do this thing. Okay, cool. That's all. All right. So select the color. Can I copy paste it? Yeah, tutorial was actually meh. So I'm gonna just pick this color, this palette, because I don't really want to spend too much time. And I wonder how I can copy paste. Okay, so I can copy hex, and I can put that hex here. So then for the other things, I can copy it here and put it here. So that should work, hopefully. And it definitely did. I'm not sure if I'm super happy. Score. So I like this one. Okay. So this bright could be actually useful for agents or something. I also like this one. What about this one? And yeah, I think I'm okay with this kind of stuff. So too bright. You think it's too bright? So the background, I'm not sure. We'll see. So baby powder is a color name. Wait, really? Yeah, apparently it is. Baby powder, nice. Grid color, we can use this for grid color. I think it looks better. I really like how it looks like. Nice. I can also change shade, by the way. Yeah. I think I can just click here and I just can, and it automatically updates them, but all right. It also supports Control Z, which is, or does it? I'm not sure how it went back, but yeah. I'm more or less okay with these colors. We'll see how it goes. It's not perfect, but red is too bright. You think it's too bright? Right. So I want to do a committee now. Enable world style of definitions. Check. It's not a baby powder? Do you know the names of all of the colors? My god. World style. mold style. Yeah. Okay, render agent. So we want to render the agent, and we're gonna do SDL set hex set color hex renderer, and we can say agent color. Right. So this is how we can do that. And the next thing we want to do, we want to render that agent. So and the agent agent color is going to be red. Well, at least I'm going to try the red. We'll see how it goes. So I want it to be bright, so we can see agents like instantly. Render agents. So for now, I'm going to render agents as the squares inside of the cells, and we'll see how it goes. So it's going to be rect. Rect. So the position is the following: agent pose x multiplied by cell width. Multiplied by cell width. And cell width, by the way, is float. You have to keep that in mind. So that means we'll have to floorf it, of course, and convert it to integer. Floorfing is intensifying. So the agent pose y. You can always add your own color palette in the PR. Yeah, so it's actually kind of... Yeah, you know what I'm gonna do? I'm gonna create a file style, and I'm gonna put everything there. So literally, so we're gonna have like a separate file where you can define all of these things. And that's exactly, I implemented this like sort of system where you... Wait a fucking second, why the fuck am I using strings? Why am I so dumb? And then I can do mathematical operations to extract the components out of it. Why am I so dumb? Can anybody tell me? Why am I so dumb? Welp, I mean... That explains why I'm unemployed. I mean, yeah. Did you guys notice that, like, when I was starting implementing this entire system, and I just missed people screaming in the chat as usual? Are you doing GA visualization? Yeah, so I'm doing visualization of a game, for which then I plan to use genetic algorithms. Alright, so and then we can include, to be fair, like I don't really want to spend too much time on that right now. Maybe style.h and also style.h, and I'm gonna do the following thing: to do replace strings with hex literals. Alright, so yeah, so what I want you to do, render agent. So I'm rendering the agent and cell height, and this one is going to be integer. So the next thing is cell width. Again, need to floorf it, int, and might as well actually do it like that. It's going to be height. Emacs is scary. So how do you fill a rectangle? SDL fill rect. Chat, do you feel rect? Classic. Classic Zozin. Let's see. So then we can have a renderer, and then we can give a pointer to rect. You fill the rect. The SDL quit documentation says the call quit in any exit situation. That's why I was wondering. Oh, okay. Unknown. Oh, because this is SDL rect, and then I'm gonna do semicolon here, and cool. But we never call this function anywhere, so it doesn't count. So next. Every time we want to render something, we render board grid, then we render all agents with the renderer, And there we go. So we have 5 agents. We have exactly 5 agents, and they look actually pretty good. So look at that red. Even though red is too bright, I mean, if there's like a little bit, like a few small amount of that red, it just gives this like accents on the background, and it just makes it look good, I think. We cannot render the board grid, and maybe that will also look good. Yeah, but maybe with the grid it will be better. Generally. Okay, so let's do a committee, and then maybe even a pushy. We're going to be trying to implement, though, I'm actually making up game on the fly, so it's going to be sort of like a Hunger Games, where we have agents that are fighting for living as long as possible. But Zojin, why use SDL? Use mesh shaders instead. I'm waiting when they add mesh shader support to SDL, so once they add that, I'm going to use mesh shaders as soon as possible. Yeah, don't worry about it. Okay. So what do we have here? Render agents. Introduce. Yeah, I suppose never. Because I don't know, like, I mean, SDL itself doesn't really have any shaders at all. Introduce what? Introduce what? Agent rendering. How would you implement separate game loop from draw loop with SDL, by the way? Like buffering, syncing between both? You make too many assumptions about how I'm going to implement. So right now I'm going to try to implement an interpreter of the game, so given the current state of the game, and then we're going to have a visualization for a particular state of the game. And then we're going to have a separate thing that trains the agents. So it's, I mean, was generally speaking, buffering, syncing, like it's a whole topic. This is exactly what we do in something, right? We do a lot of this kind of stuff in something. All right. So I want to make a small break because I need to refill my water and stuff like that. So I'm gonna do a small break. It's gonna be 3 minutes. Oh, come on. So, and then we're gonna continue with this thing. Right, let's make a small break. You guys have fun. Yo, welcome back to back. Just a second. A little bit of OCD. So yeah, let's continue. All right. So let's actually quickly fix that. I think it kind of annoys me that this is such a Pepega solution that it's kind of difficult for me to, you know, keep it. So I'm gonna quickly try to fix it super quick. Yes, English. Alright, so it doesn't really work properly, and I like how like C doesn't really complain much about type mismatching. I absolutely love it. So here what we accept is essentially uint32, right? So this is going to be the hex, and hopefully now it will actually, it still doesn't complain. It's amazing how like weak typing of C is. It's amazing. All right, essentially to extract red, right? To extract red, red is the first byte here, right? Red is the first byte. So that means I need to shift the whole hex 3 bytes to the right. A single byte, like, okay, so I'm shifting it 3 bytes, and a single byte is 8. So this is what I get. Pretty much, and I think that's it. I think this is the easiest way to do that. I'm currently working on the project Simultaneous. It's a simple grid game where the player must catch the seed. The idea of the project was to learn Q-learning, and now I'm working on the deep Q-learning approach. Cool. I'm really glad that you're doing this kind of stuff. It's pretty cool. All right, so I think that's it. So it's even easier to, you know, extract things like that. I don't know why I was so Pepega. Well, at least I learned something. Huh. Yeah, SDL set color, so it's that. Style. Next is going to be hex. We're shifting only 2 bytes here, but also we have to mask out, right? Because there will be garbage. So when you're taking this thing and you shifting 2 bytes, right? You get this thing, but then you have to get rid of this garbage. So that means you have to do something like 0xFF, right? And it would be better to actually do that for all of them, right? And for this one, it's going to be actually 1 byte, right? And for that one, it's going to be actually 0 bytes. So, and I'm, you know, I'm keeping these silly expressions, so they sort of like follow the pattern, right? Even though this kind of expression like pointless, you can remove this entire thing, and here instead of 1 multiplied by 8 you can just have 8, but this creates like a regular visual structure. I kind of like that they follow the same like pattern, and you can see the you know, the idea here. So I think it's quite important. Yeah, it's sort of like a self-documenting code explaining what exactly it's doing. Does that make sense? For some reason I like to leave these kind of stupid expressions just to complete the pattern, even though they're pointless, but they sort of keep like they retain like additional documentational information. All right. And yeah, so let's give it a try, and everything works correctly. So the colors are extracted correctly, they displayed correctly, so this is exactly what we would expect. So, and that makes it way simpler. So look how much code we actually removed. So yep, you don't need any of this shit, you can just extract the bytes out of the number. Like, I mean, come on, just let the language do the work. Why are you doing it yourself? All right, so refactor style H to use hex literals instead of sisters. There we go. I'm gonna push that right into the repo. Code is a living documentation, yeah. Code is a documentation that never gets outdated, because every time it gets outdated, it stops compiling, so people are forced to update it and keep it up to date. Yeah, so that's everything I can say about code. So I want to improve the look and feel of the agents. I want to make them triangles. I really want to make them triangles. But as a first step, I may try to just make them smaller to see how they're gonna look like. Please tell that to my UML professor, for fuck's sake. Yeah, so I wonder if your UML professor works in an industry. To be fair, I don't work in an industry either, but I still write applications that I try to keep maintainable and usable for other people, which might count as work in industry. I don't know, because I'm doing the same thing as people in industry. You also draw UML. Do you draw UMLs at work? Actually do that? Jesus Christ, that's cruel. Oh no, okay, so that's actually good. You knew, yeah, I see. He doesn't really work in industry nowadays. He just mentors student projects. Oh, I see. Which kind of makes it worse. Yeah, probably. Maybe he worked in an industry when there was like hype around OOP, and that's why he picked up this UML stuff. Or maybe that's, I don't know how unis work in your country, but in Russia we have like a standardized program for all of the unis. So, hello Campersan, welcome. Hello Hanzin Nation, welcome everyone who just joined. We're just doing a little bit of visualization for genetic programming. So that's all. Yeah. All right, agent padding. So we're gonna have a little bit of agent padding. I don't know how it works also. Oh, I see. So let's say that we're gonna have like 10 pixels padding. So that means I'm gonna add this padding here. There we go. Plus, then minus. And it didn't work because it's agent padding. Agent padding. That was weird. It's supposed to actually subtract. Oh, we actually have to yeah, subtract it twice. I see. So that's what has to happen. Yeah. So now they're a little bit smaller. And we can control that padding, and now these agents are, yeah, they even look a little bit better, I think, that way. The problem with these agents is that we cannot see their direction, and it's kind of Pepega. The best way to indicate the direction of an agent would be to draw them as triangles and basically point the pointy side towards the direction. But unfortunately, SDL does not allow to draw the rectangles, or does it? So we can draw lines, and we can implement our own triangle rasterization. So I already did that in one of my games, so I might as well actually steal some code from there so we can draw triangles. Alright, so make agents a little bit smaller, and I'm gonna push that right into the repo. Alright, so let's find the game, and we're gonna yoink some stuff from there. So it's SDL, renderer, draw triangle, there you go. So we also have fill triangle. I think in this particular case we need to implement something called fill triangle. So let me find render C, fill triangle. It's actually quite elaborate, I would say. This entire thing quite elaborate. And it also depends a lot on points and stuff like that. So, okay, we'll have to introduce the notion of a triangle. So let me try to do that. So triangle, struct triangle. Oh my god, it's actually a bunch of vectors to floats. Oh shit, stealing that from something is gonna be pain in the ass. That's for sure. Welcome back, Arne. So we're trying to steal some code from nothing, especially how to fill triangles, but it kind of looks very painful, so I'm not sure if I'm gonna do that. But yeah, let's just go ahead and do that. So essentially, what I want to be able to do though is something like this: fill triangle. There's gonna be int x1 y1, and then we're gonna have like 3 of them. And that should render the triangle correctly, hopefully. Renderer, see. So we also have different slopes and stuff, so I might as well just copy paste. Yeah. Oh shit, I also have to sort the... Oh my god. Triangle sorted by... Where is this function? Oh yeah. That's very strange. So... It's a very complicated algorithm. So maybe we can find like a ready solution. Maybe. An extension library that does have triangles. I think there were, I don't know, third-party dependencies, SDL, SDL2GFX. So it will make it less buildable on other platforms because it's an additional thing. Sorry. So I'm gonna just not do that. So let's introduce something like triangle then. So it's gonna be a triangle. You know what? I'm gonna even have like a separate module here, triangle H, right? And this is where we're gonna define all of that. So this is a triangle, and we'll have to define a structure triangle. And are you implementing your own graphics library again? No, only triangle thingy. Sorry. You know how to solve it, include nothing. Yeah, okay, well, let's just implement it super quick. Okay. I don't want to use SDL-GFX, I'm sorry. I don't want to use it. I mean, would it be nice that like you just have triangles but you don't add additional dependencies? Wouldn't be that cool? I think that would be actually cool. Have you read the DDD book? What are your thoughts on it? I've never read it. I don't have any thoughts on the book. I'm sorry. So, I don't really read books. But, yeah. I'm trying to. So, I started to read the second chapter of SICP. It's going so well. It's not as annoying as the first one. Oh, somebody asking about include guards. Freefall, it's called include guards. So Google up this thing and read about it. So yeah, it's a usual pattern. In case you accidentally include, and that will happen by the way, the header twice, it will prevent that. So it doesn't allow you to include it the second time because this thing is already defined, so it will just basically remove everything. So that's how it works. Pragma twice. Pragma twice. Haha, very fun. Triangle. Triangle C. Triangle H. So I'll have to implement that. And let's start the process of porting. The process of porting. So triangle C math, and we need this thing here that will, you know, swap things for us. Zoe's in jail. Zoe's in jail. Yeah. So what I need to do here, actually, oh, god damn it. Maybe that's exactly what I need to do. So it's gonna be like that, then like that, then can your Vim do that? Can it? Can it? I don't think so. No, I don't think so. So we need a way to swap ints, I suppose. Some way to swap ints. Let's literally define a thing called swap ints. Swap ints because it's C. So we're gonna have 2 pointers here. And we're gonna have T, X. Nice Chitorino width. Well, it's a perfect width for my site. I'm sorry. Alright. Alright, so I modify that. So it's already so I think I swapped everything. Yeah, so it seems to be working. So now if I can swap something here, I should be able to do it like that. Swap ints. Alright, and I actually need to copy paste those ints twice. Yeah. I'm gonna use Emacs Magic one more time, chat. I really wanna use it. Look, boom. 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 Isn't that epic? I think it's pretty fucking epic, my god. So here we have to have actually X, X, and here we have to have Y, Y, X, X, Y, Y, and last time X, X, Y, Y. Right, so we have a thing to do here. Triangle. So in the original code, SDL rendering something something fill triangle. So first thing we do with a triangle is we triangle sort by Y. So that's the first thing we do for sure. And let's see if all of that compiles. Well, it doesn't compile, and I think I'm gonna do a little bit of a separate compilation this time, because why not? I haven't done that for a while. So essentially, yeah, to be fair, maybe fuck it. So it's gonna be something like triangle C, then triangle H, and I'm gonna just, you know, put everything together. We'll see how it goes. So we don't have a renderer here, so I'll have to include not include it, but include SDL to SDL.h, and it worked. Beautiful. So, and here I have 0 for some reason. I don't think we need 0. I don't think we need 0. I don't think we use it for anything. Yep. So it's gonna be void. There we go. So the next, yeah. So now we need to port the whole thing from here, right? So now we need to port the whole thing from here. I wonder how difficult that would be. Hello, Hertz and Pots, welcome to the stream. And we'll need these functions here. By the way, we have FAB ABS, but do we have ABS here? Oh, we don't need that actually, because it's literally checking whether they're equal or not. Yeah, so essentially we just check whether they're equal or not. We don't need this kind of stuff here anymore. We don't need this kind of stuff here. And similarly, this is just checking whether it's... Wait, no. Yeah, it's also checking whether they're equal or not. So I'm actually porting algorithm from floats to integers. That's exactly what I'm doing here. So, and then we're constructing a new triangle here, and we're making a new triangle here. So, and we need like to implement this function fill. So the idea of the whole algorithm, by the way, so for those who doesn't know, of rasterizing of the triangles and stuff like that, it's actually pretty straightforward. We're only implementing rasterization for the triangles that have a flat top or flat bottom, right? So yeah, so we're only considering triangles that look like this, right, where we have flat bottom, or the triangles that look like this, that have a flat top. So, and the way we're rasterizing them is we just render, like we just draw lines, like horizontal lines, like this, and we're filling it up. And yeah, so these are two different cases. So essentially, if you have some weird triangle that looks like this, the first thing you do is you actually split it into two triangles. The first one is with a flat bottom, and the second one with the flat top, and you sort of rasterize them separately. So that's pretty much the whole algorithm. I don't remember the name of that algorithm, but this is usually how it's done, and this is basically what I'm implementing. I mean, I already implemented that. I'm just porting that from a different project, so I don't have to implement it myself. Even though re-implementing that from scratch would be interesting. But that's the idea. Porting still in, I mean, yeah, so, and that's why we have these conditions there in the code, right? So we check whether it's a bottom flat or top flat. And if it's neither of those, we actually construct a new triangle, right? Construct a new triangle and just render them separately. We basically split everything. And also there's a special case where it would be nice to like draw like line and so on and so forth. Anyway, so we don't have these functions yet. Let me quickly implement them. So this one is going to be this. And it's going to accept the triangle. Right, so it's accepting the triangle. And so the second one is going to be top flat triangle. So void render. This one is void t. Void t. Fuck. And I also want to assert that none of these things are implemented. Fill bottom flat triangle is not implemented. And another one is fill top flat triangle is not implemented. What is that? Well, there we go. Another frequently asked question. All right. So what do we have here? So let me actually quickly go through everything there and see how all of that compiles. So it doesn't have assert. We're going to include the assert to the page. Fill triangle, conflicting types. Why are you conflicting? Stop conflicting. Ah, you see that? You see that? Yeah. And maybe I'm gonna actually do something like this. Alright, next one. Okay, so this is pretty straightforward. I just have to do that and like that. Cool. That one. Oh, and so apparently since I don't check any stupid error codes. Oh my god, this is such an old code. I was doing so much stupid shit that I don't need to do anymore. Like none of that is needed. You can. That's why I was so scared of this code, because it was looking so like branchy and stuff like that, and I thought it's complicated. It's fucking not. It's fucking not, dude. Like, don't overcomplicate shit. I'm just talking to myself. Like, don't mind me. I like to talk to myself. Yeah. Look how. Oh my god. So, and then I can. Yeah, we can just do it like that. But it would be nice to check for the error anyway. Yeah. All right. What do we have here? And it's gonna be like this. Then it's gonna be like this. What's next? Aha. So this one is gonna be slightly different. It's gonna be x4 and y4. So, and where is the? Aha, I see. ICPC. And this is the second value. Cool. So I wonder if I can actually come up with a macro to do this kind of stuff. Probably can, but I'm already doing it without the macro. And the longer I do it without the macro, the less opportunity I have to use the macro. So I don't know. And I'm almost done it. So yeah. Sometimes it's you trying to automate things longer than it would have taken to you to not automate them. It's kind of weird. Is it not? I think it kind of is. Alrighty. So in here, I think we can do something like this. Yep. Storming into your flat in the middle of the night, shouting to lay flat on the ground while they're searching through every single corner of your house. Then they apologize and leave. And what? You have to clean up after them, and you woke up anyway, so you're retired and you're not getting any more sleep today. Are you okay? Is everything okay at night? That sounds pretty awful. Hope everything's okay, though. Alright, so x1 is essentially gonna be t x1 Anna both. Hello, haven't seen you in a while. Welcome. How are you doing? Okay, just a second. I phased out. So this one is going to be x1, t x1, y1. I mean, this one is going to be x2, y2, and this one is going to be x4, y4. So this is how we're going to achieve all of that. Does KGB still exist, or have they been renamed to something else? In Russia they have been renamed. In some ex-USSR countries they are not. It actually depends. Okay. Okay. This is gonna be something like this. It's gonna be x2 t y2 x4 y4 x4 y4, and this one is gonna be x3 ty3. Okay, seems to be okay. X, Y. This is not Y, by the way. This is not the point. Then like this. And I think we don't need round F in this particular situation. I think it's kind of redundant. I think it is kind of redundant. Emacs. Emacs doesn't want to do what I'm telling it to do sometimes. Quite often, to be fair. I don't know, maybe it's something with my keyboard. Or something with my fingers. Or something with my brain, who knows. Okay, so I make this shite compilable. And by the way, the shite doesn't look as scary as it used to look, right? So it looks exactly as I explained the algorithm. We check if it's a bottom flat triangle, we render it as a bottom flat. We check it if it's a top flat triangle, we render it as a top flat. If it's neither of those, we split them up. So this is the point at which we split them. And we render two separate triangles. And then we add an extra line because sometimes they don't connect perfectly. So I just add an extra line just in case. And now we just need to port the field bottom flat triangle and field top flat triangles. Should be pretty straightforward. Should be pretty straightforward. Let me see. So we're gonna go back to the renderer, right? So it's gonna be field top and field bottom. They're actually pretty similar. So you just do slopes. Oh shit! Does the slope require like floatness? I think it does. Okay, so we also have YY. We also have a cursor, but every time we render all of that, we round F all of that. Okay, so let's actually try to port all of that. Let's try to port all of that and see how it goes. Should be pretty straightforward. Of course, I don't need to do any of these conditions. Oh shit. I just have to do it like that. So you just have to do it like that. And I think, yeah, I think we do need floats here. Let's go through the compilation errors. Let's go through the compilation errors. We don't have trace assert. Then this one is essentially this. And I'm just gonna adapt that. Just a little bit more, because this schema kind of changed, and I really want to keep it like closer to SDL. That's why I'm doing all that stuff. I hope I didn't make any mistakes though, because if I did, well, that would be actually kind of sad. At the same time, I don't really know why we're doing it like that. Y and Y1 and Y2 are already integers, so yeah. Alright, one more time. So am I doing everything correct? I think so. Alright, scan line. This one is TY0. Wait. What was the Y0? Oh shit. Okay, so let's actually keep them, because yeah, I feel like I'm not gonna properly keep track of everything. Alright, so let's just keep them like that. Chat is so wholesome today, my god. Cannot believe that. Such a wholesome and nice community. So proud of it. So proud. Anyways. So what is that? Yeah, let's remove that. And I think that's it. I think that's the whole implementation of this thing that is compilable. Hopefully, except this part, of course. except this part. And again, we have a little bit of fucky-wacky here. And reference to roundef is not found because we're not linking with the math library. Math library, not math library. Oh, okay, I'm not talking about math. Math. Alright, seems to be working, seems to be working. Okay, so we implemented the bottom flat triangle rendering, and we need to implement the other one. So that was bottom flat. And what about top flat? So let's just copy paste it there, and I'm gonna copy paste it there, and I'm gonna remove that, and let's do the same shite. Let's remove that. Let's remove that. Let's go back. Let's go back, and boom. Don't need anything else. So this one is a keg. This one is not a keg. So I'm gonna quickly just do it like that. I had editors in the web browsers trying to emulate Emacs. What? You mean it's kind of very specific. Are you talking about a very specific text editor? I think I know what kind of text editor you're talking about. Oh shit. Okay, so it's actually alright. Chat, look, I'm gonna use Emacs magic. A boom, a boom, a boom. Haha, can you even do that? Dab. Alright. Fuck. Okay, well, it almost worked. He's talking about those online editors. I see. Okay. Yatanasov is here. Hello, Yatanasov. Welcome. Welcome. Very glad to see you. So, okay, let me actually jump there because there should be no return 0 here, I think. Not in the mixer, not used to Control W from readline. Yeah. All right. So this is how much space it takes. I mean, how many lines it takes to implement a rendering of triangles from scratch. Isn't that epic? So yeah, I think it's pretty epic. Oh, and also. Yeah, we actually, yeah. All right, so the time has come to test that big. Let's fucking test that and see if it works or not. So we're gonna replace this kind of stuff with a triangle. So where's the render agent? Render agent. Here we go. So instead of rectangle here, we're gonna compose a triangle. I'm gonna compose a triangle. So it's gonna be a triangle. Triangle. So I think we need to include the triangle.h render agent. I think there is like a iMenu thingy which lets you quickly jump to functions. Render agent. Yeah, there we go. Okay, so let's think how exactly we're gonna render all of that. So we're gonna render one point up there. So it's this point as far as I can tell, right? So it's literally this point. But this is only an x, right? This is only an x. Then this is the second, this is y. The second point is going to be the same but down there, so that means it's going to have the same x, but it's going to have like a slightly different padding. So the padding is going to be for y is going to be like that, and the third point is going to be like this, but we're going to add we're gonna add the width. We're gonna add the width. So this is an x width. Right, this is X width. So this is X width, but in terms of height, we have to add this kind of stuff, but divided by 2. I wonder if it's gonna work. I feel it's not gonna work, but let's give it a try. Render triangle. Fill triangle. So we're trying to fill a triangle. Yeah, there we go. And this is what we're trying to fill here. And it doesn't really work properly because it's a renderer. First try. Who's a god coder here? Yeah, so there's no like anti-aliasing there. God damn it, it looks like shit because of that. Small triangles. Well, but maybe it's not that important. Maybe it's not that important. So we only need that for visualization. I wonder if, like, with SDLGFX, it's gonna look better. Let's actually find out. Do they implement that, like, somehow differently? SDLGFX specifically. Do I have it installed, by the way? SDLGFX. Okay, but I don't have the... It feels like it's not the ZL... Yeah, it's kind of unfortunate. So we'll have to use that. Yeah, there's nothing I can do about that. We have to use that. Excuse me. SDL2... Oh, yeah. Good point. Thank you. Yeah, nice. Thank you so much, Odin. You are the best. So, let's try to install that. Fuck. I already have it installed. Jesus fucking Christ. Love it. Every time I'm looking to install a library, it turns out it's already installed. Who would have thought? Alright, grep SDL2. Yeah, SDL. GFX. Okay, makes sense. All right. So is there any documentation for SDL GFX? I wonder. Any documentation? So this seems to be like official website, but where's the documentation? Doxygen generated API documentation. GFX primitives. So we have some sort of GFX primitives. Can we click on them? I'm trying to click on them. Triangle. Oh shit, oh my god, the Dark Reader goes crazy. Oh boy. Okay, we're not gonna use Doxygen because apparently Dark Reader doesn't really work well with Doxygen. Web technologies. So I'm gonna go to the source code of GFX and whatnot. GFX SDL2 GFX. GFX primitives. Okay, so I'm gonna just Google search for triangles. There's no triangles? Trigon. Okay. Trigon. Seems like the thing that we need actually. Seems like a thing that we need. Alright, so let's use that. So Trigon. I don't know why they call it like that, but they sure did call it like that. So, oh, what? Why do I have to? Oh, and they accept color as UN32. So the GFX actually literally implemented the style system that I reinvented here. What the fuck? Or did... Excuse me? Like, I just made this thing like for myself for convenience, but now I can just pass these values to GFX library and they probably gonna work? The fuck? Excuse me? That's kind of funny. Render agent, okay. So, I think I should be able to do the following thing where I can, you know, remove that. Yeah, but PTTV is like a third-party thing, and I don't know. Okay, so here it is. So we already have a renderer, so we're gonna pass the renderer here. In this particular case, we have sint16s instead of ints. Sint16. And here, oh, also it doesn't indent properly because we have incorrect syntax or whatnot. Oh, yeah, I mean, okay, sure. And the color is going to be agent color, I suppose. So we can move this entire thing here. Yeah, classic Emacs. I do agree with that. Fucking classic Emacs. I have such a weird, like, hate-love relationship with this editor. I cannot stop using this, but I mean, all right, seems pretty good. Let's see if it's gonna do anything. Trigon implicit. Okay, so I forgot to include this kind of stuff, so I should be able to include SDL2 GFX primitives. Wait, how is it called? Yeah, here it is. SDL GFX primitives. There we go. I think if everything is done correctly, you don't have to prefix things like that. You can just do it like this. That makes sense to me. And let's see if the quality of this thing is going to be better. If it's going to be better, we're probably going to use GFX. SDL2 GFX. Alright, is it going to compile and define the reference? Are you fucking serious? Excuse me. So package config C flags SDL2 GFX. All right, looks good. What about libs? Looks good to me as well. Did I do a fucky-wacky, like a major fucky-wacky somewhere? Yes, I did. I never used the variable packages that I defined. So it's pointless to add any packages here because I don't use that variable anywhere. Well, what I have to do here is that. Of course it doesn't fucking compile, I mean, sure. Classic. Okay, but it didn't fill them. It's just literally made the triangles out of them. Right, so it doesn't count, I think. So what about field trigon? Okay, so you basically have to add like word field there. Sure. Render agent. Render agent. Field trigon. Is it gonna improve the quality of this thing? I think the quality stayed as shady as it was with my code. I think what they literally did... Oh, wait a second. That sounds very interesting. AA polygon. Is there a field AA trigon? Let's find everything field. Field by field polygon. Alright, let's try AA trigon. So I'm not sure what's that, but maybe it's something good. So does it accept? Yeah, it accepts the same parameters. Let's actually see. Yeah, let's actually see. Yeah, first of all, it's not field. And it's trying to do some anti-aliasing, I suppose, but it doesn't really work. What if it's field? Well, it should have it. Field? Nah, it's not a thing. For some reason. Maybe I'm missing something, maybe I'm blind, as usual. But yeah. Maybe it's something about polygon. So we can have polygon, AA polygon. Nah, I think we'll have to suffer. Just find the two triangles, one field with. Wait a second. Wait. That, I mean, you're probably joking, but that might actually fucking work. Wait a fucking second. So we're gonna actually draw the field one first, and the AI, like AI one, on top of it. Okay, and if I do it like that, the quality is worse. So, okay, we're gonna do it like that. Thank you so much, Showtime. We're gonna do it like that then. This is so Pepega, I love it. Alright, so that means I can just finally remove the triangle shit. Yeah, we'll see how it goes. Epic. Nice library. By the way. Okay, so let's remove the triangle shit that I actually ported there, so we don't need it anymore. So, not wasted time at all. Not wasting time at all, by the way. Software development, my favorite. Alright. Okay. And, okay. Boom. Boom, boom. Looks good. Alright. And let's do a committee. Introduce SDL. Wait a second. Dependencies SDL2, SDL2, GFX. Right, and SDL2, GFX. By the way, where's the official site of GFX? Is that the official site? I think it is. You know what? I'm gonna actually give the link to maybe a copy of. Alright, I guess that's the official website. Oh shit, cool. I don't understand what is the official website, but maybe that's what it is. So I said that you can use a set hint. Ah, yeah. I think we can use that. Render scale quality. Okay. So first of all, let me finish documentation. Thank you so much. Thank you, Adnan. So I'm gonna give this link here. Maybe. I'm gonna give it here. All right. Introduce SDL GFX dependency to render agents as triangles, and I'm gonna push that right into the repo. Epic. So let's take a look at set hint. What do we have here? SDL hint render scale quality. But what kind of hints we can have there? So I have an idea. What if we grab for SDL hint render Grab our N. I think it's a scale quality, but I'm not sure if it will improve it. So I'm gonna try it. If it's not gonna improve it, then whatever. But if it's gonna improve it, then we're gonna commit it. Blind. There is link to all hints. Oh my god, I'm sorry. Yeah, I'm really sorry. The color theme also makes it kind of difficult for me to see. Yeah, thank you so much. So I suppose here's the category hints. Oh shit. N, T, or AA. That's a lot of hints actually. I don't know which one should I use. I don't. Okay, I don't think it's that important. So, all right. I think whatever quality we have right now is okay for now. So I don't really want to go down to like this rabbit hole too deep. I'm sorry. I'm really. Ah, God damn it! I didn't want to close it. Okay, but thank you for the link. So now I'll know that this thing exists, and maybe I'm gonna use it at some point. So because the focus is not on that, the focus is on rendering, like is on the game itself. So what I want to do, so even though they're rendered as triangles now, right? They're rendered as triangles. They are not rendered according to their direction. Right, so and that's kind of the problem. So let's take a look at that one more time. It should be, there we go. So basically we need to be able to rotate them accordingly. And to do that, I think I'm gonna save the triangular meshes into the arrays, where index of the element is gonna be associated with the renderer. You were joking, but I mean it's all right. Like I probably need to change my glasses because I do have problems with seeing things lately. So I think I just need better glasses. No, it's okay. Everything's okay. Don't worry about it. Yeah. Everything's okay. So yeah, what I want to do is essentially have some sort of array, like triangles array or directions array. So agents dirs, right? So and essentially here, where's the direction? Here's the direction. Here's the direction. And we're gonna have 4 of them. And here, for each of these things, we're going to have 6 numbers, x, y, x, y, x, y of the 3 points of the triangle. Yeah, and this can be the ints. And I wonder if we want to define them somehow specially. Poke. Oh, you implemented the calculation properly. Nice. Congratulations, by the way. Congratulations. So, essentially, what we're gonna have here is different triangles. I think I'm gonna store them in float because I think it's gonna be easier to define them. And there we go. That was weird. Right. So in here, we have the following thing. The first point is... Okay, I need to draw a little bit. Because I cannot visualize this kind of mesh in my head. So, yeah. My paint, here we go. So first direction is the right. So that means the coordinates are gonna start from 0. So here's 0. this one is going to be 1, and this one is going to be, I guess, also 1. I think the positive y is going to be also there. So, and essentially the direction to the right is going to be something like this. So it's going to be that and that. So in defining such mesh on this kind of coordinate system is going to be super easy, right? Because the first point is 0, 0, right? The second point is going to be, let's do that clockwise. By x it's 1, x is 1, but y is going to be half, right? And the last point here is going to be 0, 1. So this is the first point that we, the first triangle that we defined, and it looks at the right. So math is important for programming. What kind of programming though? So is math important for writing books? Depends on what kind of book you're writing. If you're writing a math textbook, well, yeah, you better fucking know math. But if you write like a novel, then no, like there's no math there. See? You see my point? All right. So the next one is going to be up. And it's going to be something like this. Right. The first point is going to be, what if my novel is about some math PhD students? So in that case, you have to know math. Like it's just, it does not contradict to whatever I said. It's just, you know, the more different kind of things your novel works with, the more things you have to know. It's just, it is what it is. There's nothing contradictory here or wrong or anything. It's just, that's how it is. So this is 0, 1. So this is the first point. 0, 1. The next point is going to be x, 0, 5. But y is going to be 0. And then this is 1, 1. All right, we defined direction up. So this is the triangle for direction up. So when we're going to actually render it on the screen, we're going to shift and scale the whole thing. Yeah, we're going to shift and scale the whole thing. All right, so what is the next direction? What is the next direction? The next direction is left, and the left direction is this. Yeah, there we go. I hope I didn't fuck up too much. So the first point is 1, 0, 0, 0. It's unrotating. So you think I can define like a single mesh and rotate it myself? I probably can, but I'm too dumb for that, especially right now. So yeah, maybe, I don't know. So 1, 0. The next one is 1, 1. And then we have 0, but 0, 5. Yeah. That will be Monk Omega, probably. So we'll see, we'll see. All right, so the next one is down. Next one is down. Next one is down, and that down is 0, 0. Then 1, 0. And then 0, 5, 1, 0. Okay, I think I defined all of them. And essentially, if you have a direction, you just pick the corresponding mesh, scale it, shift it, and render it. Looks good to me. All right. So let's actually try to do that. Xorification operation. Nice one. So What we need to do here, essentially, agent direction, agent steer, is that what it's called? Yeah, agent deers, and that gives us that mesh that I would like to copy somehow. By the way, if I do something like this, where I have like 6, will that actually copy the array? Will that even compile? Well, I think like semantically it should copy the array, but I'm not sure if it will actually compile that. It does not compile, okay? If I got the semicolon here, anything else? Invalid initialization, okay, so that makes sense. But I mean, it just means I have to do that slightly differently. So this one is 0. So I just need to update position. So how am I gonna scale that? Alright. So I'll have to literally do things like that. x1, y1, x2, y2, x3, y3, and that's how we'll have to do that, I suppose. Because we'll need to scale these things at some point. How are we gonna scale them? 1, 2, 3, 4, 5. So I suppose we'll need to scale them according to cell width or cell height. So if it's an X, cell width, so we'll have to add that cell width there to every X. And to every Y we have to do a cell height. Right. So this is cell height, and there we go, we have a scaled mesh. And we also want to move it somewhere. How we're gonna move it? It depends on the position. Agent pose X. Right, agent pose X. And we're gonna add that X to each individual X here. And for Y situation, it's gonna be pose Y. So here's pose Y. There we go. So now we have a scaled and shifted mesh. So now I should be able to do the following thing: x1, y1, x2, y2, x3, y3. Looks good to me. An intentional rhyme, by the way. And I might as well actually take the whole thing here and just boom, boom. Will that compile? Will that compile? We'll see. Oh shit, that didn't work. Well, at least they are rendered in different directions, sort of, but they are mashed up together because I didn't, you know, do the position properly. The thing I have to do here, shit, is I have to. Let me quickly do that. I have to multiply these things by their corresponding sizes. Like this, and that will, yeah, so now they're looking in different directions, but what's funny is that there's no other directions for some fucking reason. The question is why? I don't know. So maybe because there's no other directions accidentally. I mean, it does not contradict to the fact that maybe there could be no such directions or anything. We can try a very interesting thing, essentially. We can have agents count equal to 4, right? And when we initialize in the agents, each agent here, we can assign their direction to I, and that will basically naturally check all of the possible directions. So let's see if it's gonna work or not. Yeah, there we go. So here are all of the possible directions. Yeah. But I don't like the fact that they're as big as the cell itself, right? They're as big as the cell itself. So we'll have to scale them down a little bit, right? We'll have to scale them down. Again, I can define some sort of padding there. Padding is going to be like 10 pixels or whatnot. Or maybe we can actually put it like that. So there's an agent count, and I'm going to define agent padding. It's going to be like this. Render agents. So what we have to do here, so we scale it, but since we're going to have a padding, the scaling has to be slightly smaller. It has to be slightly smaller. Oh my god, there we go. And we're simply gonna, I suppose, subtract twice of the padding. Agent padding multiplied by 2. Alright, so that makes it a little bit smaller. We can test it. So as you can see, it made them a little bit smaller, but their position is still not aligned with the center. Right, it's not aligned with the center, and to align it with the center, we have to add a little bit of padding there. Right, so let's quickly do that. We're gonna do add agent padding. There we go. And now they're aligned, and now on top of that, what I can do is I can increase the padding, for example 20 or maybe 30. And they're pretty small, but let's make it like around 20 maybe. Yeah, there we go. So now we have these agents that actually have direction and stuff like that, and yeah, it's pretty cool. It's pretty cool. So maybe it could be something like 15. Yeah, looks okay, I would say. Looks okay. Render agents, agents direction. Alright, I'm gonna push that right into the repo. So now we have their agent direction and stuff like that. Do we need anything else from the visual part of this situation? I don't think so. I think that's so far okay. From 5 PM to 10 PM for some reason. It's really strange, but maybe you just have to go sleep then. All right. So I suppose now we need to come up with a brain for the agent. Why isn't the error in SCC pooped itself? I don't know. So yeah, now we need a way to encode the logic of a particular agent. So the way I want to encode the logic of an agent is actually quite similar to Turing machines. So essentially, each agent, they're going to have their internal state, right? So let's actually introduce something like this. So on top of like having a particular position, they also may have a particular state. Right, and state is going to be integer. So this is the state integer, and the behavior of an agent is described by a table where we have the current state of the agent, what they see around them. Right, they may actually, what they see in front of them. Do they see a foot in front of them? Do they see an other agent in front of them? Or do they see an empty cell in front of them? Right, so here's the table. So first thing here is going to be state, then environment, then what action the agent have to perform in this particular situation, what kind of action has to be performed, and what state it should switch to after performing the action. Right, and the whole logic, the whole brain of the agent is going to be a sequence of these things. Right, the current state of the agent, in what it sees in front of it because it has a direction, what action it has to perform, and how to switch to the next state. If there is no such combination, it will always perform, let's say, nothing, right? It will literally do nothing. And that way of describing the behavior will make it easy to mutate the behaviors and apply, genetic programming. I hope so. I've never done genetic programming in my life before, and this is basically my experimentation with this idea. And I borrowed that idea, by the way, from a Turing machine. Initially, I wanted to actually apply a genetic algorithm for Turing machines, but then I thought that maybe it's not that interesting. So something like actual living creatures that fighting, playing Hunger Games would be a little bit more interesting, and that's exactly what I want to do. And what's interesting, what mutations are going to consist of? Mutations are going to consist of maybe adding a new row into this table, or maybe removing a new row, maybe adding an additional state, maybe removing the state, and so on and so forth, but we also have to keep track of, so we have to be careful so the agents don't go into the state from which they can never escape, right? Maybe the next state is going to be like something like 3, but state 3 is never actually mentioned anywhere in the table, so they actually reached a hold state in which they cannot do anything, right? And that, we may actually allow that, if you think about it. We may actually allow that. So maybe some of the agents that may reach such unescapable state will never survive. So, yeah, it's kind of interesting. So the next step is going to be actually coding this table, and then we're going to use our visualization to see how the agents behave with a certain table, right? So once we have this kind of stuff, we can make an engine that breeds and selects the agents and finds the one that is the best for the particular environment. Make sense? Make sense? Yeah. To be fair, maybe the agents also have to be aware of themselves, like how much hunger they have and how much health they have. But it may make it a little bit too complicated, so I'm not gonna do it for now. All right, so I want to make a small break before I actually dive into this kind of coding, and I think it's gonna be very interesting. So basically, each agent is a small Turing machine that works on 2 dimensions, because Turing machine works in a single dimension, but this one is going to work on 2 dimensions. Sounds good. Small break to 3 minutes. Let's actually put 3 minutes here. All right. Zozin Suvun. All right. Boys and girls, let's make a small break. You guys have fun. Yo, welcome back. So yeah, I was late a little bit. I'm sorry. I was late for a couple of seconds, but I'm back. Alrighty. So let's code this shite. So the table is gonna be what? I don't know. We can code like a single row of the table, right? So let's code a single row of the table. It's gonna be type def. You missed the surprise. Did you guys have a surprise? I'm so sorry. I'm so sorry. Thank you so much for the surprise. It's actually a good surprise. I'm so sorry. Thank you so much. I really appreciate that. Wilkins gifted a tier 1 sub to Anaboth. Thank you so much for supporting the channel, and Anaboth, welcome to our epic surprise club. How about that? Do you like the surprise? Yeah, cheers. Absolutely fucking epic. While dealing with metaheuristic, the way to do is to encode the agents in a continuous n-dimension vector. And then you have decoding, blah blah blah. Cool, thank you so much. I really appreciate your help. Okay, so let's define the row. Let's define the row. So how are we gonna call that? Because I want this thing to be called like agent brain, right? So this is an agent brain, so that thing is a brain cell. It's a single brain cell. Basically we have a state, and then we're gonna have environment, and it's basically what the agent sees, right? So, and what agent can see? Environment. Let's see. Type def and come on. Cheers. Environment? What the fuck is environment? I'm literally blind. Oh, no, you're right, I'm blind. So I'm gonna just call it env. I think it's gonna be like a little bit easier. And this is gonna be just env. And environment is gonna be env nothing. Right, we see nothing literally in front of us. Then we can see another agent, and we can see food, right? Yeah, so that's the thing we can see here. Then what kind of action we can perform? So it's going to be just actions, and the next state. There we go. Brain cell needs a semicolon. Sure. So, and then we're gonna have a brain. So what's gonna be the brain? Type def struct. Brain is a bunch of brain cells. Funny, right? So this is it's gonna have a count. Wall. We don't have walls yet. That's what's interesting. So unless we introduce walls into the model, we're not gonna have them. But yeah, once we introduce them, so we can add them. I mean, let's introduce wall. Why not? Sure. So and then we're gonna have a what? Excuse me. I guess we're gonna have like a pointer, like cells. Maybe I'm gonna use like a flexible array member. Cells like this. Yeah. So here's the brain, and the agent, I suppose, is gonna have a particular brain, right? To be fair, we can have like a... So, to be fair, this is an agent state, right? So this is agent state, this is its brain, and so far everything looks okay. So far everything looks okay. Action. So we don't have actions for some reason. I do remember we defined actions at some point. Yeah. Okay, everything's compiling. Everything's compiling. So, I don't really want to keep this thing like this. I think it needs to be organized somehow, like, better. Yeah. So maybe we should have something like game. Right, the game itself. And the game itself will store all of the agents, right? All of the agents. Also, it will store the positions of all of the walls and the positions of all of the foods. That's very interesting. So what's interesting, the only thing we're expecting from this genetic algorithm is to learn that if you see food, you have to perform action eat. If you see wall, you have to try to rotate or escape it. If you see other agent, you have to try to attack. If they can learn at least that after like a little bit of randomization, that would be actually pretty cool. But yeah, so yeah, we'll see. We'll see. That's actually pretty good base for genetic programming, I think. So I want to define something like position and whatnot. So it's gonna be pause. Oh, wait a second. For the food, we also need a marker. And for the food, we need a marker that food does not exist anymore. And for the agents, we also need a marker that it's dead. How can we indicate that the agent is dead? I think we can just add me see food, me eat, me see wall, rotate. The last part got me. Thank you so much. Yeah. Cute KGB agents. Oh yeah. All right. So let's introduce food. So we can have food. Food is now countable. All right. Foods count. Did you guys know that food is countable? Yeah. Well, I mean, it is actually countable in some particular circumstances, but not always. Alright, so let's add this thing. Please eat that enemy too. So the idea is going to be the following. So if the enemy dies, it will drop the food. So that's how it's going to go. So the agents won't be able to instantly eat each other. They have to first kill. And then they will drop the food, and then they can eat that food. So if they manage to actually run that, that would be actually pretty cool. So how many foods we want to have? We want to have like at least 4 foods, right? So maybe all of that should be just a dynamic array, because who fucking cares? Drop food equals turn into food. Yeah, essentially, I think. How much food? How many? Ah, I see. Yeah. But I mean, in our case, food is countable, so how many foods? So, and the food right now has a marker, eaten. Whether it's eaten already. If it's 0, it's not eaten yet, so that makes sense. And then it also has a position X and position Y. Position Y. So we're also gonna have walls, because why not? So it's gonna be wall, and wall is basically gonna be just a position. And I guess that's it. Walls count. So we're also gonna have 4 of them. So, and here's the game, and when I render agents, right, so I actually render all agents. I suppose what I need to have here is a render game, right? So maybe I'll get instance of the render and the game, and then it will dispatch and render agents and stuff like that. So yeah, let's implement something like render game. SDL renderer, right? Then pointer to the game. So probably constant pointer, because rendering is not gonna modify it. Alright. So, and when we're rendering all agents, so I can just copy paste this thing here, and I'm gonna remove this function because I don't think it's useful. So we're rendering agents, but we're taking agents from here. Okay, to do foods are not rendered. Walls are not rendered. So the question is, how are we gonna render food and walls? So that's an interesting question, I gotta say. So we also need something like init game, which takes the pointer to where game is, and it's gonna simply initialize that. It's gonna initialize the agents for sure. Yeah, there we go. So we don't need to do that anymore. And let's try to recompile that. Okay, so when we're initializing this thing, I do game agents. Init game, and I wonder where I'm gonna allocate the game. I'm gonna just allocate an instance of a game here, and initialize it with 0. Then I'm gonna initialize it, and then render game like this. That would go. Yeah, everything seems to be working. Everything seems to be working. We have quite a lot of code, to be fair. So, but not that much. So, Introduce agents brains and formalize the game struct. Whatever that's supposed to mean. I don't know. So yeah, I'm gonna push that right into the repo. Everything I develop is actually available on GitHub right now, so I'm pushing actually live to open source repo. Feel free to check it out. So what's gonna be the next step? I think we should have a way. Yeah, we need to also have a way to step the game, like to go to the next iteration. Step game. I guess that's it. So it's gonna be like a simple step of the game. Stepping game is not implemented. There we go. And I wonder how we're gonna step the game. We might assign like a special key for that, SDL key down. So every time you press a key, it's gonna step the game one time. So let's quickly do that. So, and we need to find out what kind of thing it is. So it's key. Key sim, and let's actually assign space here. I think space is a pretty good candidate. Case SDL key space break, and it's gonna be step game. Step game. It's gonna be like that. Einstein. Subscribe for 3 months. Thank you so much. Thank you so much for 3 months of Twitch Prime subscription, and welcome to our epic genetic programming club. Epic genetic programming club. Epigenetic. Yeah, it's an epigenetic programming club. It's all right. Thank you so much for supporting the channel. I really appreciate that. All right. So step in the game. So we also need to draw the foods and walls. It's gonna be fun, chat. It's gonna be fun. The only problem here is that I'm afraid that, like, I guess it's okay. So when we're initializing the thing, let's iterate through all of the foods, right? All of the foods. So it's going to be food I, and position X is going to be a random int range from this thing, right? And then Y is going to be height. There we go. So just, you know, random position of the foods, and similarly we're going to have a random position of the walls, right? So this is walls. So this is supposed to be foods, by the way. It's supposed to be foods, and this is supposed to be walls. There we go, there we go. And does it... Okay, so we do initialize them, but we don't render them, that's why we cannot see them, right? So did we drop some frames? I didn't see any dropped frames on my side, I'm sorry. So maybe it's something on Twitch. So, yeah. Alright, so let's try to render some walls. Right. So we're gonna iterate through all of the walls. Walls count plus I, and essentially it's gonna be SDL rect. So we're gonna take the position of the walls, walls I, pose X, but it has to be multiplied by cell width, right? It has to be multiplied by cell width. This one has to be multiplied by cell height. And I'll have to floor fit. It's gonna be int. And yeah, similarly, I have to do it like that. Alright, so we also have to set the color appropriately. SDL set color hex, and we have to provide the renderer, and we're gonna say wall color. And we need to come up with the wall color. Where's the coolers? So what we're gonna use for the wall color? We might as well use this as well, the same color as the color of the grid thing. Yeah, sounds like a pretty good idea. So it will blend with the grid. And maybe even look okay. So let's go to the style. So this is a grid color, and it's going to be the same as a wall color. I might as well actually say it's a grid color. See. So, and usually you're supposed to do it like that in case the grid color is an expression. So you wrap it into the parentheses so nothing leaks. And yeah, there we go. So cool. Now we need to try to render all of that. So it's going to be SDL render. Render fill rect, I suppose. SDL render fill rect. So this is a render, and then we're gonna provide this rectangle here. Okay, so here are the walls. So we're rendering the walls. Alright, so the next thing we need to render is the food. So in case of a food, I think we probably want to render them as circles or something, but I'm not sure if it's gonna work out. Mighty Seth 777, welcome to the stream, really glad to see you. How are you doing? So user include SDL2. Let's take a look at the GFX. Let's take a look at GFX. Do we have circles? Do we have circles? We do have circles. So can I have field circles? Oh my god, this is so Craigasm. We can have field circles, so we can render them as field circles. Okay. So let's use that. I think it's gonna be super cool. But before we do that, I think I need to commit whatever we have. Well, maybe not. Maybe I'm gonna finish the foot and then we'll see how it goes. Less than foots count plus I. Okay, so here's the function that I want to call, and I need to calculate the position. So the position is essentially... Is it me or some lines thicker than other? No, it's not you. It is like that, but it's artifacts of, I think, this function. Logical size, because it resizes to fit into the window, and maybe that's the artifact of that. So I just ignore it for now. But yes, it is like that. Okay, so we need to find the center. So I need to find the food. I, position X. So here's the position X. I have to multiply it by cell width, right? And I have to add half of a cell width, right? Half of it. So then we're gonna have a radius, and the radius is quite important. So this one is gonna be Y, height. I think radius, foot color, is gonna be probably minimum between cell width and cell height. I know that there's no minimum in C, I just write in pseudocode. So we take a minimum between them, and maybe we subtract some sort of a foot padding, right? So we subtract some sort of a foot padding. And I want a floor full of that. Super quick. By the way, is there like fmin? I think there's fmin f. Yeah. I kind of remember that. Let me check it out. Fmin f. Fminf. This is not what I meant, Google. Thank you. Christian channel, by the way. So yeah, there is a fmin f. Well, in that case, fmin f would mean fuck me, I'm not famous. The fuck? Why do I have this knowledge now? Like, why do I need that in my life? Alright. Alright. So this is a floor situation. And that's why I didn't use Google for quite some time. Alright, so we don't have a foot padding. So I'm gonna put foot padding somewhere here. Let's say that foot padding is gonna be something like this. The same as agent padding, so might as well actually just indicate that explicitly, because why not? And we don't have a foot color, so because it has to be defined here. So we're gonna define foot color. So what we're gonna use as a foot color? Maybe green. Let's use the green one. It's gonna be the foot color. So this one is gonna be FF. And I guess I did a fucky wacky and a little bit of oopsie doopsie. Why are they transparent? That's really strange. And it's not the color that I expected, so what the fuck? That's really strange. It will be nice to avoid spawning walls and foods right in front of the agents. Yes, I know. We'll get to that. Don't worry about it. We'll get to that. So first of all, the radius. Yeah, the radius is actually too big, so that means I'll have to divide it by 2 first. It has to be divided by 2. And only then, yeah. So it looks a little bit better, but I don't understand why it is transparent and why it is not the correct color that I specified here. It's supposed to be green. But this thing is not green. What the fuck? So that's a good question. What the fuck is going on? Anti-aliasing. Well, you probably just joined the stream. RGBA. Oh shit, probably. That's actually kind of bad. Because, wait, seriously? So, oh fuck. Alright, so that means maybe I need to change my stuff so it's compatible with everything else. Let's quickly do that, I suppose. So right now it's gonna fuck up everything, but that's not big of a deal because we're gonna go ahead and fix that. So we're gonna go to SDL set. What was SDL set color blah blah blah. So an alpha is actually the third one, right? So we just basically need to swap it like that. So this is the alpha. And this is RGB, so... Well, that was weird. Wait a second. My brain doesn't want to work. I have to do it like that. Yes, that's what I wanted to do. Yep. So, does it work now? Seems to be working. Yeah. No, it's completely fucked, especially considering BGRA. Okay, so let's actually find, let's actually look it up in this thing. Include GFX. OpenGL standard is BGRE. Alpha is 0, not 3. But I mean, yeah, but I mean 0 is how much we shift, right? So 0 is how much we shift. Look. Yeah. So that means we don't shift anything, and then we take this this thing. So if we want to take alpha, we sort of shift this amount of bytes and only then. Yeah, so don't worry about it. I mean, how could you know? So yeah, and this is really strange. So, okay, I can change it like that. Let's try BGRA. So this is BGRA. Maybe that will actually solve that. And no, it's completely wrong. So it's definitely wrong. But I mean, wait. It's not enough. Alright. It's not enough. I'm confused. Just trial combinations. Yeah, that's probably what I have to do anyway. So, can I just not use whatever GFX suggests me? Can I just use my own thing? And does GFX even have... does GFX even has documentation about that? There's only 12. I mean, factorial 4. What is factorial 4? Oh my god, why does it so slow? Jesus Christ. Yeah, 24. Nice, thank you, Haskell. Very cool. I'm streaming for 4 hours and I'm tired, chat. Oh, fuck. Fuck. Shit. Just give me a minute to catch my breath. Just need to sit here. Because my just brain doesn't work anymore. Because I've been programming like 4 hours straight. And it's fucking hard. I mean, there's harder jobs, but yeah, just a second. Everything's okay. I'm just trying to gather my thoughts. What do we need to do? Maybe we can download the source code of GFX and look how it is defined there. That would be kind of interesting. That would be kind of interesting. So for now, I'm gonna actually use RGBA because this is what I used to. And we're just gonna put it like that. There we go. Yeah, and that means I'll have to go back to SDL set thingy, SDL set. So red is this. So essentially, we can just reverse this entire thing. It's gonna be 3. It's not 3. It's definitely not 3. 2 1 0. 3 2 1 0. And like overall, I think it works, except for the circles. I think circles like have like a different format or something. Yeah, field circle color. This is a foot color, and I don't fucking know, man. I don't fucking know. So maybe specifically circle is like that, but I'm actually super curious, chat. I want to take a look at the code of GFX. Did they really fuck it up? And like in different functions, they parse this color differently? I'm really curious. Let's actually find out. So what I need to download? Maybe older versions. What version do I have? GFX. SDL2 GFX. I suppose it's 1.0.0, so I just need to download this one, and hopefully that one is the one that Debian uses. Isn't it docked in? I don't know. Who reads documentation in 2020? Come on. tar fvx SDL, and let's just go there. So I'm gonna try to find the function field circle color. Right. Grep rn. Let's find it. Oh, there is a lot of shit here, especially HTML shit, but here's the implementation. So what it uses, okay. And I was thinking about how do I parse uint32, bit shift, you know, masks and shit like that. Who fucking cares? Just cast it to a fucking byte array and just... Well, now that's a big brain time. That's a big brain time. Look. You want to see Chad versus Virgin? You want to see Chat versus Virgin? SDL set. Here's go. Here's Virgin bitwise operations. Chat type punning. Now that's what I call a gut color moment. Anyway, so it is done like that in fill circle color. The docs above say RGGBBAA. I think, I mean, how can you trust the docs? You need to read the source code because you may have discrepancies and stuff like that. Okay, so let's take a look at the field trigon color. Field trigon color. So, and what they're using there, they're implementing that in terms of field polygon color. And field polygon color, it uses pretty much the same. So this is RGBA empty. So the bars it the same way. Okay, sure. Okay, so field circle. Maybe there's something wrong with the field ellipse RGBA. Right, so we have RGBA. Okay, let me actually disable white space here. So there's a H line. I don't see any mistake here, to be fair. So they pass everything, it seems like they pass everything correctly. RGB. Yeah, everything is passed like RGBA. They also changed the blend mode. They also disable the blend mode if the alpha is 0, if it is equal to 155. I don't know, I don't see any error, but again, I'm reading the source code of a thing that I'm not currently using, so... yeah... Alrighty chat, I think this is one of these multi-stream Friday topics. Because obviously one stream is not enough to explore this idea, because I was setting everything up for the whole stream. So yeah, because I doubt it's possible to set up and, you know, come up with an interesting algorithm, genetic algorithm within a single stream. So maybe we're gonna continue doing that the next time, maybe tomorrow. So how about that? Yeah, I think it's a pretty cool idea. So essentially, I'm gonna reorganize the schedule. Tomorrow is the continuation of the genetic programming. Then on Sunday, we're gonna do game development. And on Monday, instead of code review, we're gonna do game development again. So the thing is, I received not that many pull requests anyway. So there's no point in doing Monday on the next week. Code review, I mean. So we can replace the code review with game development. And we have like a bunch of pull requests, but all of them are to the game. So we can review them on the game stream on Monday as well. So yeah, I think this is the plan. So we set everything up, and we're gonna continue doing this thing tomorrow, and hopefully tomorrow we're gonna actually start working on the genetic algorithm itself. Hopefully, because that's the interesting part. So yeah, that's it for today, boys and girls. That's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you, guess when? Guess when I'm gonna see you all? I'm gonna see you all tomorrow, because tomorrow we're gonna continue doing this shit, but I haven't updated the schedule yet, because I updated the schedule right now in my head. So yeah, it still says that tomorrow is game development, but tomorrow we're gonna continue doing this thing. Check out our schedule page. I'm gonna update it after the stream. I'm gonna correct everything there. Also, check out our VODs YouTube channel. I archive the VODs on Twitch to that YouTube channel, so it's more convenient for you to watch them later, right, if you want to stay up with the stream. And also check out our Discord server for offline discussion with the community. So yeah. While you're waiting for continuation of genetic programming, let's maybe rate somebody. What do you guys think? Should we rate somebody? Let's take a look. Is anybody streaming anything super epic? I see Nibelzayo. I don't see anything interesting. Am I late? Bye bye, the Thinor. Bye bye. Alrighty. So what do we have? We already raided Nibelzayo, so I'm not sure. Coding in chats. I didn't see anything particularly interesting. Okay, I guess I tried. Sorry. Alright, that's it for today, boys and girls. That's it for today. Love you. Mwah.